Hi, jury members, those of you here, and everyone who are online. Welcome to the Construction Worker Housing. The Construction Worker Housing Division tackles a critical challenge impacting millions of Indian workers. Construction laborers often endure unsafe, unsanitary, and uncomfortable living conditions, with women workers facing some of the greatest hardships. The teams in this division have deeply explored these issues and proposed innovative solutions for dignified, high-quality housing. I'm excited to welcome all of you all to the presentations in the Construction Worker Housing Division to see how these students aim to improve the lives of the construction workers across India. My name is Roni Titus, and I'll be the MC for today. And it's my job to keep all in time, and I'll be taking this very seriously. Our finalist teams have put in a lot of hard work. They submitted their project reports about a month ago, and today these teams will present their work to the jury. Teams, you will have 20 minutes for your presentation, 10 minutes for your Q&A. Following that, you'll be having a 5-minute break by which the team should take their models out and allowing the other team to bring their component model in. So the Construction Worker Housing Division has 2 jury members who have an expertise in net zero and resilient building. Net zero education expert, principal, sustainability, Kapade Associates. Hello, Deepa. Your entries for the 10 contests of the decathlon. Teams, your presentations will help them hear your narrative. They will assess your presentations and your mastery over your solution through the Q&A session. They may revise your source course based on what they hear from you today. Jury members, I am so excited to meet the team, for you to meet the teams today. I will need to interrupt people, including you, from time to time to help us stay on time. Please don't mind. I'm looking for your support for this. Please keep your comments and your questions to the point. So let's start with the presentation. So let's start with the presentation. The first team is team AIKYAM. They have worked on Shaurya. The project is located in Himachal Pradesh. To the jury and 10 minutes for your Q&A session. In the end of 15 minutes, I'll ring a bell, and after that, your last 5 minutes starts, and at the end of 20 minutes, I'll stop you like wherever you are. That means you won't get a 21st minute. Okay? Yeah, the team stage is yours.
Good morning to one and all present here, respected jury members, visitors, our fellow competitors. We are Team AIKYAM from SMEF's Brick School of Architecture, NVIIT Pune. We are a team of 15 students, 13 from architecture and 2 from engineering, united by a common vision. To design with purpose, building with resilience, and serve with pride, Project Shaurya is a commitment to creating innovative, context-sensitive solutions.
When you see these roads, what do you feel? Awe, pride, adventure. Do you know who uses them? All of us. But do you know who? No, right? These are the men of the Border Roads Organization. Every morning, somewhere in the unforgiving heights, they wake up and begin their day. Tools picked up and journey begins. The Border Road Organization builds roads, bridges, and tunnels in India's toughest border terrains, often under extreme conditions. They strengthen military mobility, connect remote communities, and boost local economies. While the BRO plays a vital role in strengthening the nation's infrastructure, the reality of the workers' lives often go unnoticed. This news cutout is just one example that sheds light on the harsh conditions they endure, from extreme weather conditions to the temporary shelters, which often need primary facilities like sanitation and livability.
Seeing the condition in the places like Ladakh and Sikkim, a few questions began to surface in our mind. Thus, the team came up with one solution, that is Project Shaurya. Are these dedicated workers receiving the support and recognition they deserve? Are their living condition truly acceptable? And most importantly, are they safe? The question became the foundation of Project Shaurya. During our conversation with the workers, one of them told us, "It's bone chilling out here. I can barely feel my hands. We need a proper home with effective insulation that keep us warm throughout the night." Having seen their daily activities across the slides, let us now focus on what truly matters. What is the heartfelt plea of our Project Shaurya? How can a space feel like home? A true home goes beyond the shelter. It nurtures comfort, dignity, well being. Our improved housing design for BRO workers transform temporary spaces into livable and welcoming environments.
Our project site is in Jispa, the high altitude base camp for Shinkunla tunnel construction. Perched at one of the world's highest road elevation, this tunnel slashes the journey time from 10 hours down to just 5 hours, transforming connectivity in this region. The site measures 80 meters in length and 65 meters in width with a total area of 5,200 square meters. Around 200 male workers are stationed here, primarily engaged in tunnel and bridge construction. The harsh climate, remote setting, and limited infrastructure makes it essential to provide resilient and dignified housing for the workforce. Major construction activities by BRO, such as tunnel and bridges, are primarily carried out between June and September when weather is favorable and minimal snowfall allow uninterrupted work. During the remaining 8 months, the focus shifts to repair due to harsh climatic conditions and snow-covered terrain. The environmental data of JISPA highlights key factors for climate responsive design. The windrows diagram shows prevailing winds from northwest to southwest. The direct normal radiation ranges between 800 to 1000 watt-hour per meter square, indicating strong potential for solar panels and water heating. Temperatures can drop to minus 2 degrees Celsius in winter, emphasizing the need for high insulation material and thermal efficiency. The psychometric charts for JISPA reveal low humidity and cold temperature for most of the year, with condition often outside the thermal comfort zone. This emphasizes the need for passive heating, with conditions often outside the thermal comfort zone. This emphasizes the need for passive heating strategies. The analysis lead us to prioritize insulation, solar heat gain, and thermal mass in our design. With minimal need for mechanical cooling, our approach focuses on reducing energy used through passive solar design. The stakeholder hierarchy includes central, state, and local authorities, followed by BRO officials, military units, community members, and NGOs. On ground roles are filled by contractors, BRO laborers, and suppliers. With these stakeholders in mind, we now move on to present the architecture design that addresses expectations while responding to site's unique challenges.
We designed a standard housing module of 4.5 by 6 meters to comfortably accommodate up to 5 occupants. 3 such units are grouped together to form a central sun space that promotes natural sunlight, thermal gain, and passive ventilation. By stacking clusters, we maximize land usage and spatial efficiency while encouraging community interaction. To tackle heat loss, especially in cold winter climates, we incorporated double glazed toughened glass for optimal heat insulation. These slides depict the zoning strategy adopted for the site. We have designated specific zones for the living quarters, kitchen areas and dining areas, a medical unit block, toilet blocks, and recreational spaces, all well designed in the site. Each function is organized to reduce cross flow, ensuring hygiene and operational clarity. The ground floor plan is divided into 3 primary zones: residential, communal, and service. Living quarters are paired with sun spaces to enhance ventilation and provide semi private areas for informal interaction. These units are connected via a 1.5-meter wide passage that allows smooth circulation and fosters a sense of community. To the northwest, we have positioned the communal dining hall and kitchen area supported by adjacent medical unit. Toilet blocks are symmetrically placed for equal access. The entire layout is structured to promote hygiene, functional clarity, and dignified living. The above floors mirrors the zoning and circulation on the ground floor. However, it introduces staggered units to improve access to daylight and encourages cross ventilation. Strategically positioned sun spaces channel light and air into individual units. This thoughtful arrangement enhances thermal comfort and creates a rhythmic spatial experience. The roof design integrates a continuous field of solar photovoltaic panels. These panels span across the dining hall, living modules, and service cores to provide renewable energy. They are south facing to ensure maximum solar gain and efficient electricity generation. Moving towards the site, the trees line the periphery, offering shade along the path. On the right, modular homes rise in order. A worker glances towards the sun space, open yet sheltered. It traps warmth and invites connection. The stacking is staggered with care, ensuring livability throughout. Inside the room, every inch is thoughtfully planned, from the modular furniture to the lofted beds and open windows. The space is more than functional. Moving towards the other spaces, beyond the rooms lie shared kitchen and dining areas. Each module is built to last at least 10 days in isolation, resilient, equipped with biodigested toilets and engineering hub with a space to study, meet, and plan.
The 4.5-meter by 6-meter unit accommodates 3 single beds, 1 bunk bed, study desk, a pantry, and storage, ensuring efficient use of space. Built with ISMC 100, 150, and ISMB 250 and 150 by 150 box section, it features OSB plus sheep wool wall for insulation, rests on tire foundation, and integrates solar panels and a trom wall for passive energy. The foundation uses recycled tires filled with compacted soil and aggregate, placed over a 100 PCC bed. The tires are confined within a 150 by 150 concrete block grid. A I section ISMC 250 is anchored with bolt to a 16 thick base plate fixed into the tire core. It offers a low cost, economical, and stable solution suitable for lightweight and temporary structure. Now let's look at this installation video of the module.
This shows the assembly, which is made up of foldable L panels that are hinged and T panels, which make up easy for transport and assembling and dismantling.
The exploded view details out the design. We have used tire foundation to suit the terrain, encapsulated cement panels used for flooring. MS frames are used to support wall panels, which are of OSB sheets and sheep wool insulation. Similar frames form the grid for roof with cement panels, and solar panels are fixed over it. Solar panels secured with cleats on roof frames. Simple and accessible detailing for easy maintaining. Wall assembly, MS box section form the framework. OSB sheet fixed on the top to create wall surface with thermal infill. Intersection of 3 C-section ISMC 100 forming a robust node. Bolted connection ensure ease of assembly and disassembly. C-section steel members join at 90° using a clean bolted detail. Offer structural stability at unit corner. The manual will be distributed to workers along with kit to help them construct the module. Finally, this slide illustrates the load-bearing calculation for various wall sections. It includes weight per material, specification, and structural details. The total load calculated across wall 4, 5, and 6 adds up approximately to 1,841 kilograms. This precise construction assessment ensures the building safety compliance with regional construction norms.
To ensure our housing solution meets real needs, we collaborated with VKE and Anand Jyoti for renewable energy integration. To harness clean energy on the move, we explored mobile wind turbine setups on the truck. We analyzed three real-world scenarios: moving trucks without wind, trucks moving with wind, and stationary trucks in windy conditions. The most effective with both wind and vehicle movement generated up to 4.85 kilowatt per day per truck. With a fleet of 20 trucks, this approach offers a viable solution for supplementing off-grid power needs in remote BRO sites. To tackle the challenge of indoor heating in Jispat's cold climate, we introduced a simple yet efficient solution using terracotta pots. By placing a heating rod inside an inverted pot, the system stores and radiates heat steadily even after it's turned on. Calculation shows that in a room with volume of 81 meter cube, this setup can raise up to 7.37 degrees Celsius in an hour. For our construction, we explored the use of oriented strand wood, which is an engineered wood product made from compressed layer of wooden strands. For Jispa climate, OSB 3 and OSB 4 are ideal due to their high moisture resistance and durability in exterior conditions.
These slides showcase the affordability analysis of our proposed work and housing in Jispa. with a site area of 5,200 meters square with a build-up area of 2,025 meters square. The project designed to be a cost-effective and efficient. Since the land is government-owned, the cost of the land is zero. Our proposed design brings down the total project cost of estimated cost approximately 47.7 millions compared to the baseline estimate of 79.4 millions, achieved a nearby 36% of cost saving. This slide compares the cost background between the current and base case of proposed solutions. In hard costs, we have balancing spending allocation funds not just to civil works but also to MEP services and equipments. This highlights the performance of affordability of our proposed materials and design. We have used the materials like sheep wools and OSB panels that have a low U values and high R values, offering better insulations and energy efficiency. Though the upfront cost of our design is higher than the tent and porta cabin, the life cycle as compared to making 56% more. Regular maintenance ensure the durability and long-term performances. The life cycle cost analysis compares the base case and proposed case. The base case has an initial cost of 39.27 millions with annual expenses of 0.88 millions and major replacement in 6, 12, and 18 years, resulting in a total LCC of 63.4 millions. In contrast, the proposed case has a lower capital cost, having a 16.1 million and annual cost of around 1.9 millions. The distributor replacement cost is its total LCC is significantly lower than 28.1 million. As you see, the comparison is based on the parameters like livability, sustainability, cost, setup time, resilience, hygiene, and consumption. The proposed module design is upper front tents and porta cabins by offering them the comfort, sustainability, resilience, and easy to transport.
So our proposed water system reduces freshwater demand by efficiently recycling grey water. We have reused and saved 1 million liter annually. We have 4 tanks, one for potable water, flushing water, utensil washing and cleaning purposes. We have adopted simple yet impactful water saving strategies across the fixtures like low flow, shower heads, aerators, dual flush and vacuum toilets, bringing our consumption from 14,000 LPD to 9,000 LPD. We have also employed solar pumps for the energy efficient water supply and a biochar filtration system for grey water use. Considering all of these water strategies, we came down to this pumping layout. Our design ensures energy efficiency by selecting low power appliances like BLDC fans and LED lights, significantly reducing overall consumption. As shown in the table, the annual energy requirement is around 17968 kilowatt hour per year. We achieve a low EPI of 0.23 kilowatt per square meter per day, demonstrating high efficiency. This slide highlights our energy performance. We consistently generate more energy than we consume in the peaks of May and October. This surplus energy not only ensures self-sufficiency, but also create an opportunity for energy storage and revenue. To achieve net zero goal, we have installed rooftop solar panels that fully meets the module energy needs. Based on the annual demand, it is generating around 35,926 kilowatt. In addition, we have integrated solar appliances such as solar cookers and solar street lights. Considering required light needed, we came down to this electrical layout, considering the lux level and all. The baseline carbon emission is 4.40 and proposed at 56.4, showing the reduction of 86%.
The staggered layout adapts to terrain, reduces excavation, and optimizes solar gain. Moving on to the radiation model observations, May stands out, followed closely by April and June. The winter months show minimal exposure aligning with low ambient temperature. The heat map identifies high exposure zones shown in yellow, which informs efficient placement of solar panels. The direct radiation observed has been from March, September, and October, which is moderate. Interestingly, July and August see a dip in direct radiation impact despite sunny conditions. The daylight analysis conducted analyzes most interior spaces fall within 2 to 6% of daylight factor. Peripheral zones closer to opening show up to 15%. This information validates our use of larger glazed surfaces and strategic openings. The wind analysis simulation demonstrates the wind flow and pressure distribution across the built form. The dry bulb temperature graphs helps us identify that the summer months, June through September, the temperatures remain consistent 4 to 9 degrees Celsius on a yearly average. Indoor temperatures hover around 24 degrees Celsius compared to the outdoor average of 15. Even in peak winter, when the outdoor temperatures drop to 4 degrees Celsius, we maintain indoor temperatures around 12 degrees.
To enhance the indoor air quality, we have proposed a variety of plants. These species are known for their ability to absorb volatile organic compounds, that is VOC, and purify the air. This slide outlines the core value proposition of our design. The system is modular, easy to assemble, thermally insulated for maximum comfort. Beyond infrastructure, the project delivers significant value to multiple stakeholders. It ensures recognition, promotion, social upliftment, and provides secure and dignified living. Our sanitation design includes flexibility in toilet blocks, a single unit 2.5 meter cube, for set of 2 5.05 meter cube, and for set of 3 10.5 meter cube capacity. All the biodigesters are inflatable and modular. We have implemented 3 bin waste segregation system: green for biodegradable, blue for non-biodegradable, and yellow for hazardous waste. Toilet waste is managed through anaerobic digestion, which convert waste into methane used for heating and nutrient-rich slurry for fertilizers. Finally, this slide focus on scalability. The modular design is standardized, making it easily replicable and adaptable to different site condition and requirement. This module is resilient and can be used as refuge camp and during critical war situations by the villagers and national borders. The porta cabins and the proposed unit are compared on 4 parameters of durability, livability, cost, and environmental impact.
Finally, Project Shaurya is a tribute to the silent strength of BRO workers, those who build through adversity with courage and resilience. More than shelter, it symbolizes dignity, pride, and gratitude. Shaurya is a salute to them in the form of function, feeling, and form. Through storm and snow, the journey flows. BRO workers rise where people go. No medals won, no spotlight bright, yet they carve a path with silent might. With grit and pride, they pave the land, Indian lifeline shaped by hand. Thank you.
Thank you, team. Your team did a great job. Let's hear for the jury comments and take questions from them. Monish, I'll start with you.
Hey guys, great work. I'm really impressed with the volume of work and effort that you guys put in, and it's very clear from the presentation. But like also I mentioned in the comments, if you've gone through, there are few observations right at the assumptions or the choices that you made in the design. The first one being, it's a contoured site, and your contour plan and the site plan clearly indicates the contours. We can go back to the master plan, please.
So the thing was that our unit is placed on the valley side, on the lower side.
Yes, but it's, if you can just...
Yeah.
And in the meantime, who owns the land? Who's the landowner?
Sir, so it is, so BRO works accordingly that the government provides the land, so land expense is zero.
Land expense is zero.
Land expense is zero.
So in that case, would it, because there is ample amount of land in nearby, would it be cheaper for them to go just ground floor and spread it than actually going for G+1?
Sorry, sir?
Would it be cheaper and more modular had you guys done only a single storage structure?
So we analyzed that even if we had covered the entire ground for single storage structure, we found out that there were a lot of mutual shading that was happening, and we tried to integrate a lot of natural light and ventilation into the spaces through the sun spaces that were designed. That's why we chose to opt for G+1 story. Plus, it was observed that when we were figuring out if entire modules are placed on the ground coverage itself, there was a lot of material consumption that was required, wherein if we opted for G+1, there were a lot of the supports that were used, the stanchions and the other supports, they were used multiple times in the G+1, which reduces the cost.
I think it's the opposite. So you will save on the structural strength of it. You'll make it lighter, and the amount of material that you consume. And in terms of here, it's not the shading is not the concern, it's the heat, because you're dealing with extreme cold, not the heat. You need more light. So had it been a single story, you would have actually gotten more light into the building and the heat than actually G+1.
So one more reason was now if we will destroy the land more through the foundation. If we are going G+1, we are having like 6 units at a point, which is reducing the foundation requirement and the upcoming charges as well. So we thought.
You have gone for a very super nice lightweight foundation in the design.
Yeah, but sir, that will require some foundation and excavation as well. So which will add up to our year-ended and shifting costs.
No, so the rental of the land is very cheap,
Yeah.
but the cost of construction of making G+1 in this case is higher because of the snow. So what happens in a case like this, unlike a regular construction, the snow load is tremendously high. So when you're calculating the dead load of the structure, you will be ending up designing for more, and it is not so easy to collapse it and move it like you are assuming, because if it's a G+1 structure, there'll be more components, and the variation in the components design is also different. They're not standardized components for you to pack it. So just if there was a comparison done, if you had done it like spread it, and if you had gone G+1, I think you would have probably come across different observations is what I felt. But that doesn't take away from the work that you guys put in. Like I said, I really enjoyed the amount of the intensity in the design, what you guys have done, tried doing and all that. But probably there are certain small nuances in terms of comparing with this, is what I thought. But summing up, the contours are very clear even in your site plan. If you can go to the next slides, detail. So especially when you're dealing with a climate responsive design, and the land is extremely important, that in this case, next, check this. This is contradicting what you're saying. It's not a valley in both this. Look at the lines of the contours. And your north is tilted. Even if you had to orientate the building according to the north, you would have gotten the building parallel to the contours because your north is tilted, right? So these are some, I'll pass on to Deepa.
Sir, one more answer I would like to give. The stanchion that we have used for the foundation can be adjusted according to the heights. So even if it is a contoured site, if it's some wrong here, but even if it's a contoured site, we can adjust the height of stanchion. So, and one more consideration was if it is a cramped up site, because now these module won't be carried out as campus in the next remaining 8 months. In the remaining 8 months, if it's carried in a cramped up site, that's why also G+1 would work better.
It's actually the opposite, because when you are saying the foundation can be adjusted, that's a nice argument, but in the contours, especially with all the landslides that happen, it's the cut and fill that's a problem. And we cannot cut the land in the hills. That's why one has to be extremely, you must have seen all the recent, the landslides and the floods that happen. So the basic thing is that if you follow the contours, then you don't have to go for, then you can limit the cut and fill, which will add more strength to your the structure.
So thank you for the presentation. I like the storytelling, how you started and how you ended. It was very good. You had a certain method to how you went. It's also evident in your report. It's very well laid out report. Graphics are very good, clear to read and understand. And you also addressed all the contests quite well in a very balanced way. So that's something I really liked about your work. About your questions, somewhere you've mentioned there's a trombe wall.
Yes.
It's not clear where exactly in the cluster is the trombe wall.
Just a sec. So, ma'am, the sun space, the area which is sun space, the C thing which is out here, it is the trombe wall. So it will trap heat, and other panels are covered with recycled polyester, which will trap the heat over the night period. So we have used trombe wall out here, and these are covered with recycled polyester.
So you're saying you have a sandwiched wall, right? With the OSB sheet and the sheep wool.
Yeah.
And on top of it, you also have this polyester?
Not on that C panel, we have on the remaining, where there is no trombe wall, we have attached polyester, recycled polyester layer, so that it doesn't allow heat to go out.
So it's like a plastic sheet on the wall?
Polyester sheet panel. So what we have done is we have reused those sleeping bags which will be discarded by the army, which will be discarded by these BRO workers as well. We'll reuse them and we'll attach them towards the towards the.
Does it give you an airtight construction?
Yes, ma'am. So this was one of the inspiration that we took from, so if you know Hayal University, they have utilized somewhere in the similar way, but they have also utilized recycled polyester. So we thought of if we could use that, it will actually trap a lot of heat.
So this was not evident in your presentations or your rendering or your detailing.
Yeah.
I'm not sure that even after having such low U values that you have mentioned, and you can, if the comfort temperatures could be slightly, they're quite low, even in winters. If they could be a little higher, that's something to really look into. Trom wall, I'm not sure why did you keep it inside. It could have been outside too. So that's something to think about. Another question I had was, is the floor insulated?
So floor is encapsulated concrete panels which will trap the heat once it is. So what will happen is, ma'am, the sun space will take up the heat, then the trom wall will trap that heat over the day, and the polyester panels didn't allow it to go out during the night, and even the flooring will help in trapping that heat.
What happens to the cantilevered part? That's a floor there too.
So, ma'am, that is
Something to think about.
yeah.
Because of your design, you have a lot of exposed areas.
Yeah.
Roof, floor. Typically, floor is on the ground, so even
Yeah.
that needs insulation in an extreme climate like this.
Right.
So we pay a lot of attention to walls, but we forget about the floor. So insulating floor is also important. Then if you did run your energy models, you probably see the impact of that as well. Yeah, I don't have any other questions other than this. Yeah, sure.
One small thing. What's the difference between a regular wall and the trom wall?
So trom wall is having one layer of glass as well, which takes in heat. So there is a channel above which takes in heat and throws out the cold air. Yeah.
I'm sorry, but that's not how it works.
Uh,
So, okay, the difference is the wall acts as a heat absorber.
yeah.
So there has to be a material to retain the heat during the day
Yeah.
and release it in the night. Okay? So typically when the wall becomes the heat mass.
Yeah.
Yeah? So typically a trom wall, which has a good thick mass, water is used in bottles or whatever. Like if you look at the work of Hayal or in Ladakh, Sonam Wangchuk is doing a lot of work with this, some phenomenal work. But in the night, it's also important to have like a fabric or anything to make sure that the heat is not dissipated
Yeah,
outwards but inwards,
Yes.
right? So, but given your sections, the size of the sections, it's only possible to do it with phase change material, but not with a water, because then you need massive walls for that. Anyways, I think that's the thing.
Yours is a lightweight construction,
Yeah.
and hence it kind of is
Contradicts the
contradictory
to the trom wall.
strategy.
Okay. Yeah.
Thank you, jury members. Thank, thank you, Team AIKYAM. Let's take a 5-minute break and we'll come back for the next presentation. Next, we have team AIKYAM 2.0. Their project is Project Sukibaba, and which is located in Mangalore. Teams, you have the stage. So team, for your instructions, you will have 20 minutes for your presentation and following that 10 minutes for the Q&A. At the end of 15 minutes, I'll be ringing a bell, and which indicates you have like 5 more minutes. And at 20 minutes, I'll stop the presentations. That won't be a 21st. Yeah, thank you. The stage is yours.
Greetings to all. While each division in this competition play a crucial role, they all ultimately depend on one group, the construction workers. These workers are the backbone of our construction industry, the true makers of our home. Yet, ironically, their own living conditions are often neglected, marked by poor infrastructure, safety concerns, and a lack of dignity. Currently, the materials commonly used to house these construction workers are not only detrimental to their health, but also harmful for their environment. We are Team AIKYAM 2.0 from Manipal School of Architecture and Planning, and we are here to change that. The term AIKYAM is Sanskrit for oneness, unity, and harmony, which resonates with our vision for these blue-collared workers. Our team includes passionate students from engineering and mostly architecture. I am Kushagra, and I stand here with Samar, our team lead, Michelle, and Ojaswi, all from architecture. We are privileged to work under architect Vaibhav Jain, our faculty lead, and to collaborate with Marian Projects Private Limited as our project partner, along with several industry partners. Our initiative also brings together multiple stakeholders, such as construction workers, bamboo farmers, and contractors, to name a few. Let us introduce our housing project, Sukhi Bhava. Located in Mangalore, Karnataka, the housing is integrated within the actual construction site and spans over a total of 3,000 square meters. We have achieved a build-up of 11,165.5 square meters with a ground coverage of 69.7.6 square meters and a FAR of 0.38. The demographic data shows here the 200 male construction workers for whom this housing has been designed. During the planning stage, we accounted for both basic and special requirements to ensure a dignified and functional living environment. The site falls within warm and humid climate zone of Karnataka, characterized by clayey soil and significant contours. The macroclimate analysis reveals high southwest winds, heavy annual rainfall, consistently high humidity, a max temperature of 36 degrees Celsius, and only 274 comfort hours a year. Whereas the microclimate tells us surface temperature reaching up to 45 degrees Celsius, peak wind speeds of 4 meters per second, groundwater at a depth of 4 to 5 meters. Few passive design strategies for this climate are mentioned below.
The team set 12 different goals to achieve a more sustainable and efficient design. We have also included communication and a startup as our goals. The site zoning massing has been done as per the orientation and the flow and the circulation at the site level. The site has different areas like kitchen, living units, first aid room, open zones, electrical room, and toilets. We have a 3-meter wide entrance in the center with 2-meter wide pathways connecting all the modules. The toilets are on the either sides of the site for easy accessibility from different parts of the modules. We have in center we have dining and kitchen as it is the common space used by all 200 workers. We have also provided a central courtyard open space for extra activities. A swell runs through to the boundary of the site, ending in a recharge pit for stormwater management. The first floor is similar to the ground floor, and there are few renders of the site. This is a walkthrough of the site. This is a 3-meter wide entrance, the open space for social gathering, the farming area near the kitchen for extra activity, living units with extended veranda for shading, which also connects all the modules together, the toilets on the back, on the sides of the site. The kitchen in the center as common space. Our modules measure 6 into 6 meters with 2-meter wide veranda in the front and can accommodate up to 8 users using bunk beds. The plinth are set on the foundation with lower part of the joinery coming over the plinth that will hold the base beams. The base beams are then attached, then fixed with the joinery using the upper part of the joinery and bolted with 10 dia. The 3-meter height columns are placed in the hollow section, and then we have 2-meter into 2-meter bamboo panels, which is made up of bamboo culms and finished with plywood. Bamboo wall panels that are made up of bamboo strips and finished with paint. The top beam is placed and which holds the truss, steel truss. The roof panel is also bamboo strips covered with tarpaulin for extra water resistivity. Our G+1 module has a height of 7.4 meters, while kitchen is a height of 4.4 meters. We have used joineries which are easy to understand for the workers and assemble and dismantle at the site. The structural analysis shows that our modules are stable in all 5 zones of seismic zones with 1.5 Newton per kg square meter of weight. These are the service plans, site electrical plan, individual electrical plans. So we have 2 LED bulbs and 2 wall fans in each module. Site plumbing plan. The first innovation is joinery. So we have divided the joinery in 2 parts to make it easy to assemble and dismantle. This part will actually come on the plinth, and then we will place the beams, and this will be covered with tightened with the upper part of the joinery. So it makes it much more easy to handle for the workers. Another innovation is that our plinth can change we can change the height of plinth from 450 mm to 900 mm as we have contours at our site. On-site farming is provided for mental health well-being and having extra skill to the workers. They also save on the vegetables as they get the fresh vegetables from the on-site farming. We have developed micro turbine system which can be used on the slope to generate electricity during the rainy season, as a rainy season in Mangalore sometimes lasts for 6-7 hours per day. So during that time we can't use solar panels. That's why we have used turbine system which can generate 6.9 kilowatt of energy per hour. Our modules are not just for construction workers, but they can be used for different purposes like affordable housing, medical booths. These joineries help us make the module flexible and help us achieve different forms as per the site requirement. The extra bamboo pieces are burned and used as bamboo charcoal dehumidifier. We collaborated with 9 different industries and used their products in our design to make it more sustainable and feasible, achieving a maximum number of SDGs. We have used bamboo because it is widely available in India. It is affordable, sustainable, and it has durability, strength once we treat it. We have also compared bamboo with different materials to understand how feasible it is in these kinds of projects. All the bamboo used has been treated using boric acid to make it termite resistant, which adds up to the life cycle of the bamboo. And external faces of the bamboo has been paint coated or used tarpaulin to make it more waterproof.
So to optimize health and well-being, we have used a proper furniture layout, and we have used optimal cross ventilation, and we've given buffer spaces like verandas for heat relief, and we've also used low VOC materials to improve the indoor air quality. As mentioned before, for the walls and for the floor, we've used layered materials for providing insulation, and Out of the total number of occupant hours, 90.6% of this is comfortable according to the IMAX standards. And we have also calculated the ventilation rate to make sure there is optimal airflow within our modules. So coming to lighting, we receive 410 lux of natural lighting within our modules during the day, which eliminates the need for any additional lighting during the day. But we use two 9-watt bulbs for lighting during the night. And according to our CFD analysis, we have good airflow and cross ventilation in our modules, providing thermal comfort. And we have a first aid room with an attached washroom, which helps with routine medical checkups and immediate assistance. We also have used strategies like mosquito meshes and use of vegetation to repel pests.
Our design reduces the energy requirements by implementing various strategies such as using bamboo walls as well as using more efficient lighting and electrical systems and using internal and external shading devices to overall reduce the energy requirements. We are able to decrease the energy from 26.87 to 17.06 kilowatt hour per meter square per day. And our site also has 18 solar panels which generate 55 kilowatt hours of energy on average daily, and a biogas plant which produces 4 hours of cooking gas, which help achieve a net zero energy. We simulated a model across various climatic conditions, and we found that our module is thermally comfortable across multiple climates. Through solar incident, by checking the solar incident radiation, we have found that there's a decrease of 500 kilowatt hour per meter square in our design, which helps decrease the overall solar heat gain. And the daylight analysis and CFD analysis show that our modules are comfortable and receive adequate daylight as well as adequate ventilation. Our site receives 3,600 mm of rainfall per annum, and this rainfall is collected and filtered through rainwater filters with 80% efficiency. This water is used for the day-to-day activities, and the used water is recycled in eco-STP, which has 70% efficiency, overall achieving 150.6% net positive water. Our design reduces the water requirements to 64.5 liters per day by using various efficient strategies such as using more water efficient fixtures as well as bio toilets which reduce the water requirements. Here we have just elaborated a bit more on the various strategies we have used. By using bamboo as a primary material, we have reduced the EPA, sorry, the embodied carbon of the walls, roof, and flooring. And here we have just showed the reduction in the embodied carbon of the various modules on site. And overall, we have achieved a 58.27% reduction in embodied carbon on site.
So there are a number of risk factors that are concerned with our site, especially the location and the context. That includes earthquakes, floods, landslides, etc. And each of these factors we have carefully considered, and we have come up with design solution and strategies to be able to tackle these issues. And these are some of the design strategies we have used, including structural system, etc. This is our fire exit plan. So in this, there is a main 3-meter wide accessway which is used for emergency vehicles. And throughout the modules, there are 24 fire extinguishers of different types based on its uses. And they are located at strategic locations at regular intervals. And we have a clearly marked fire exit and assembly point for safe evacuation. And for resilience quantification, we have considered various factors like passive performance, resilience in recovery, and autonomy of critical services. This is to make sure that our design can function even during disasters. So when it comes to our critical services like energy and water, we can go for up to minimum of 2 days without any outside intervention. And also talking about waste management, we have used a 4 dustbin system that is biodegradable, non-biodegradable, hazardous, and recyclable waste. And this ensures efficient waste segregation.
So far, we have addressed the challenges and proposed a solution. Now, let's talk about the implementation. Recognizing the modular and versatile nature of our unit, Team AIKYAM 2.0 has devised a business strategy to maximize reach and accessibility. Our model caters to a broader customer base through its two purchase options, which are the EMI model and the rent model. Each unit costs about rupees 1,88,000 to manufacture, and we have set the selling price at rupees 2,35,000 with a 25% profit margin necessary to continue our production. There is an additional shipping and installation charge at the requirement of the service. The EMI model works as the every month you have to pay rupees 22,520 over a period of 12 months, whereas in the rent model you have to pay rupees 9,400 a month with a minimum rental period of 3 months and a 10% discount of a rental over 12 months. Our module is not only innovative, but also cost-effective. Based on the Karnataka schedule of rates, the estimated capex is about rupees 5,280 per meter square, which is 27.4% lower than the baseline scenario. By situating the construction worker housing directly on the construction site, we eliminate the land cost at rupees 9,400 a month. The cost per worker is just rupees 18 a day, or 3% of the daily wage in exchange for a safer, more comfortable living environment. These improved living conditions are not only affordable, but also thermally comfortable with an operative temperature of 24.31 degrees Celsius, sustainable as it reduces embodied carbon by 58.27% and is spacious as per NBC guidelines. It also achieves net zero with the use of solar panels and 150.6% net zero water with the use of rainwater harvesting. It also achieves multiple sustainable development goals by the UN as stated. Due to its temporary nature of investment, worker housing is a cost-sensitive topic. Team AIKYAM 2.0 mitigates this by prioritizing modularity, scalability, and ease of assembly, disassembly, making it a more safer investment option. From the project partner's point of view, providing the facility for 5 years would cost him about 61.5 lakhs. Our proposal to charge the construction workers just rupees 18 a day would earn the project partner a return on investment of rupees 4 lakh and 15,000 over a period of 4 years and 9 months. Moreover, the project partner also returns the ownership of the construction worker housing module, which he can reuse over multiple sites with a minimal cost of disassembly, transport, and reassembly at the another site. We believe user satisfaction to be the ultimate goal. After completing stage of our design, we went to 5 different sites and interviewed over 52 construction workers and asked what they feel about our design. This is the outcome of our little survey. Also, to streamline our engagement, we have also developed a mobile app which offers features such as modular housing type selection, material selection, buying options, as well as feedback from users, to name a few. With the remaining time, I would like to distribute some pamphlets designed by us for the marketing of our construction worker housing module. I would like to thank Solar Decathlon India, our esteemed jurors, my team, my faculty leads, and everyone responsible to make it possible today for us to stand on this stage. Thank you.
Thank you, team. You did a very good job. Now, let us hear the jury comments. Yeah, Deepa, I'll go with you.
So there's a scannable QR you can use to check out the installation process and about our team and more.
Thank you for the presentation. I like that you introduced your group like team members, which is a good thing to do. So there are a lot of good things overall in your project. However, I felt that it needs good resolution. You've thought through some things and other things probably not thought through as much. So, you know, like it's a work in progress, so do take that feedback positively. Few questions I have for you. So I'm thinking which one to pick first. Okay, you've looked at modularity, and it seemed from your explanation, it's focused on the main housing part of your design. Are you following the same modularity in the other structures, which is there in your project, like that kitchen block?
Yes, ma'am. So our modules can be expanded, not like we have developed 6 into 6 meter wide module, right? But using these module joineries, it can be expanded to even 8 meters into 8 meters or 10 into 10 meters as per requirement. Like we
Have you applied that in your design for the kitchen block?
Yes, ma'am. Here we have, but we have used trusses of bamboo rather than steel in the kitchen to cut the cost. But yeah, the joineries have been applied in the modules, and yeah, it just have been introduced in the modules, not in the kitchen.
Yeah,
kitchen,
okay.
not in the
That's something to think about, like, because if the entire campus is to be dismantled, of course, the biggest component is the housing, but there are the supporting infrastructure as well. So how do you do that? Do you leave that behind? Do you demolish it? Do you also think of modularity for that as well? A lot of times, toilets are also modular in real life. But that is to think about. And in terms of design resolution, you can think how it could be applied. Another question I have is, you have bamboo for walls, roof, basically everything, right? And the U value seems to be 0.7. Now, this what you have on the table is like a floor, is like a wall, or it could be either.
So that is the floor, ma'am,
Huh.
and this is the wall.
So you see, this is 1:1
Yes, ma'am.
scale.
This is 1:1.
You see that big air gap?
Yes, ma'am. That we have used as insulation.
Such a big air gap does not insulate. It conducts heat. Okay? There is a amount of gap which you can use for insulation purpose. So this is like a literally hole in the wall. And so it's unlikely that you'll get the U value that you are thinking you will get. And the other advantages of it are because it's ventilated. If ventilation is your strategy, then it's quite ventilated. But otherwise, it is not insulating, this kind of section. So something you should think about and model it properly. So you also, when you make it, you may think, isme insulation kaise milega? It's so thin and there's so many, gaps in it. So again, what you model and what you make may not be the same, but really need to be careful about that. Having said that, you've shown ventilation seemed to be a big thing in your presentation. You've shown some CFD, airflows, and I could quickly pull out the report. They are very low airflows, like 0.03 meter per second or 0.05 meter per second. So we can't really conclude that there is enough ventilation just because there are arrows going everywhere. You have to study the data and then really think that is it adequate? Do you have to review the size of the openings? It needs to be thought about, right? Then concluding that you have good ventilation and hence there is comfort. So yeah, those are my questions. Over to you.
Ma'am, the wall panels that we have used are finished with a mat, and then we have paint over it. So it's making fireproof and making it airtight as well, while making it waterproof as well. So just the thing is, like, we have used windows for the ventilation, and these gaps are given so that when we are, let's say, if we at any other site, insulation is required, any sort of insulation is required, these gaps can be used to fill that material inside and provide insulation.
Infill there?
Yeah, it can be used as an infill. Let's say if it's being used in a cold region. So to provide much more insulation, we can have any infill inside. In our site, it is coming comfortable as per the simulation without any infill.
Good job, guys. I think overall the presentation is very impressive. I like the details, and especially the details, because some of these details are very close to how you would address a real life project. So that way, I think we can see the amount of research that you did in the construction systems. But one big question that I have, you use bamboo everywhere.
Yes.
Why not the structure? Which is the biggest component for you in the carbon footprint, embodied carbon?
So, when we talk about bamboo, the culm diameter, it differs for bamboo, type of bamboo, and it also differs, the size of bamboo, it will differ. So we wanted to had a structural system that is, you can say, universal, that can be used anywhere. Because once you have different dia of bamboo, a structural system becomes a major, major thing to solve. So that's why we had bamboo panels and roof panels using a split bamboo.
No, with a detail like this, the interesting detail that you did, with the, I agree with you that the diameters, you don't get 80 millimeters per precise or 100 millimeters. There's a variation. But one of the challenges in this, apart from the embodied carbon, is also that you're using two materials with two different expansion coefficient. So what happens in this is that the gap in summers, the metal will expand. It also creates a thermal bridge. And there'll be a gap between the panel and the column that you created, creating waterproofing issues, because they too expand differently, right? So had it been that your panel is coming outside the column and you covered the columns without any gaps, would have made it much more seamless from exterior. And if you want to go with the same structural system, so that you will not have any gaps, because that will definitely create waterproofing issues for you 100%. Okay, that was one question. And the other thing is it's like I said, it's really nice spaces, your corridors, everything, the southern side is thought through, and you have that. But I think one small observation is that you could have had much larger overhangs, because especially for bamboo, no matter whatever waterproofing that you did and the thermal paint, it's a natural material, subjected to cracks, expansion happens. So none of this is going to last. It wears off after some time. So having the only way to protect that is having large overhangs, so that even the material, if it expands with natural, the behavior of the material, you'll still protect it from the exterior and the weather conditions. And so yeah, I think these are my major thing. But I think, practically saying, your design has even a great potential if you even consider structure also in bamboo. It wouldn't take away. Even now, I think it is good as is, but I'm just saying that that's also not a bad option. Your carbon footprint have come even drastically down. It has good, really tensile properties for it's a good replacement for steel, right, bamboo?
So I would like to add, the one reason why we did not go with bamboo and rather we went with steel as a structure, if you can see, steel is also where we spend the most to manufacture the module steel, but steel is somewhere we did not want to compromise, because we can also go up to G+2 in certain seismic regions, which we were not able to with bamboo as column. And also, it's a kit of part assembly. So steel has a long lifespan. So bamboo, after a few years, after let's say 10, 15 years of rough use, it will deteriorate, okay? And so we can just screw it out and we can replace the wall panels, so making the life cycle of our modules much more higher with the use of steel for structure. The skeleton is all steel. That's one major reason why we went ahead with steel.
I also want to point out that I like your thinking about this EMI versus rent and kind of, taking this modularity to the other level, making it feasible. So I wanted to ask you, how is it that you came up with the maintenance of 600 rupees a month?
That was just a maintenance part was a rough figure to make it an even 10,000 a month, as the monthly rent is 9,400, and also maintenance is mostly replacement of bamboo panels, which won't be that often. So just to make it an even figure of 10K, we came up with 10,000. Rest are like.
So this does not include solar PV and all. It's just the structure, right?
Yeah, this is just the solar. It's up to the project partner or the user to add solar panels and all that. But
did you check with them? Is this do they like this proposal?
Yes. Also, the project cost is inclusive of solar panels and all the other costs, whereas the module cost is we're just talking about the manufacturing and the selling cost of the module.
So what
itself.
were they leaning towards, EMI or rental?
No, they were leaning towards the EMI option, actually direct purchase or EMI. Rental, because that would cost them more over the years, and they want to have it permanently as for their ownership. That's why.
Team, the time's up.
Thank you.
Jury. Thank you, jury members.
Thank you, ma'am. Thank you, sir.
Thank you, Team IKM 2.0. We will now be taking a short 15-minute break. The teas will be served just outside the room, and we'll come back for the third presentation. Thank you.
The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through.
Well, welcome back to the presentations of construction worker housing. Our third presentation is from team Climate Smart. They have worked on project Nelalidu from Kadalur. So team, you'll have 20 minutes to present your work to the jury. At 15 minutes, I will ring a bell like this. You won't have a 21st minute, which means at 20 minutes, I will stop you and ask you to end your presentation. Okay, team, the stage is yours.
A very good morning to the jury, fellow students, and everyone present here. We are Team Climate Smart from NIT Trichy, here to present our take on the design of construction worker housing. So from the census report of 2001, we know there are 14.6 million construction workers in India, and there is an increase of about 8.5% from the year 1999 to 2008. So our project is a response to the prevailing unsafe and unsanitary and inadequate living spaces that is present in the site. And we, as a team, also envision safe, stable, affordable, and modular living spaces. And that brings us to our project, Niralidu, Togetherness Under One Shade.
We are a team of 15 members of a multidisciplinary team. Our faculty lead is Professor Amalan Kaushik. Our project partner is Muthuswamy Construction, and the industrial partner is Tata EcoFirst. Our project adopt build on operate model, in which the contractor build on and operate the model. So they are handling the occupancy, maintenance, and ensure the reuse for the future. The need of the project is to improve poor living condition, improve health and well-being, which will impact the productivity and efficiency, and improve the social stability and worker retention. So we need to aim and to provide affordable housing and modular housing units to meet workers' accommodation needs. The site is 10 acres of land in Kadalur, near Government Higher Secondary School in Penayar Road. The west side of the site have 2-floor school building, and the east side have the construction site of hostel building. The project partner requirements are waste management, community areas, affordable housing, and easy assemble. We have 130 workers with 90 bachelors and 10 families. The age ranges between 18 to 45. Working hours is between 8 a.m. to 6 p.m., where families and children staying in the house throughout the day. By optimizing planning and use of passive design strategies as well as the local material, we have achieved the reduction in embodied carbon, energy usage, and cost of the construction. Also, try to achieve zero dependency on HVAC and efficient water management. Our project prioritizing circular economy principles. Coming to the context, the site located in Kadalur, Tamil Nadu, which falls under warm, humid climate, bamboo, coconut palm, and clay are some of the regional material available. And currently, the workers live in temporary shelters made of aluminum corrugated sheets. The average annual temperature is 28.2 degrees Celsius, where the hottest month is May, and the coldest month is January. Except summer months, the humidity is higher during occupied hours. The winter wind is from northeast and the summer wind is from southwest. We have given the strategies according to that. There's a slope of 3 feet and the lowest point of the site is southeast. So the thermal analysis of a box model we have identified that the south wall should face within 15 degrees of true north to get maximum winter and minimum summer heat. The problems seen in the site are mentioned here. The notable ones are unstable and cramped units, improper waste management, unhygienic toilets, and poor lighting and ventilation.
The design is approached with 3 main ideas: minimal site disturbance, maximize user comfort in site with minimal pedestrian circulation, improve indoor living condition of workers. In zoning, the living spaces are zoned on the northern part of the site because the southern part had trees. So the play area is provided under the trees, Recreation spaces are provided at 2 zones to encourage women engage in various activities. Common spaces like dining and restrooms, which will be used by workers from construction site during the daytime and lunch, are located centrally to the living spaces and construction site. The design form is approached with longer wall facing the south. Central courtyard space is created to increase airflow. Void is provided in all direction to encourage wind from all direction, and connection between blocks are introduced to improve circulation. Site plan. It can be observed that the site plan does not disturb the existing site condition. 2 entries are provided. One main entry on the northern side of the site for the act as the main entry, and there is another secondary entry on the eastern part of the site for the workers to enter the construction site. Also, service entry is provided on the northwest side for heavy vehicles to enter into the site. Pathways are provided along the contour without disturbing the site, and kitchen space is zoned next to the dining spaces. The kitchen material used for kitchen is corrugated sheet, which was recycled, and in case of any fire from the kitchen, it does not spread throughout the structure. An additional play area is also introduced between the units, and the amphitheater is provided at the lowest point of the site so that the contour acts as natural steps, and the amphitheater is under the trees so that it creates a very good environment for the workers. The family unit and bachelor unit is segregated vertically. Like the family unit is provided in the ground floor, and the bachelor unit is provided in the first floor to ensure privacy. The morning period when the spaces receive maximum heat gain is occupied only by the women and kids. So that is also an additional reason for providing family unit on the lower level. The entry for bachelor unit is provided near the entry to the site, and also the dining spaces which will be used by the bachelor is also provided near the entry itself so that the bachelor does not enter into the family zone. So the whole zone is connected by corridors for easy circulation, and all the spaces designed for kids are located near spaces occupied by women to ensure maximum safety. Like the daycare is located next to kitchen, and the play area is located next to the recreational spaces. And the density distribution map shows what type of user occupies the site at different time period. So the slide shows the detailed furniture layout. The unit size is 5.4 by 3.6 meter, and we have provided bunk beds which can accommodate up to 6 workers. And also the different type of windows we have used in a single unit can be seen. We have used eco coolers, wooden louvers, and we have also given lower window on the clear story level for the hot air to escape through stack effect. And the corrugated sheet which we have recycled are used as doors in all the units, and the section through various spaces are shown to understand the connectivity between spaces. So all the strategies that we have employed to increase the living condition inside the unit is mentioned there. The solar panel to reduce the heat gain, and lower window at clear story level to increase stack effect, cross ventilation, southern corridors to decrease the heat gain, eco coolers, and the choice of material to reduce the heat gain and also to reduce the sound from the construction site, and family unit on the lower level. This slide shows the overall user experience, how the user perceives each spaces in the site. So the assembly process of single unit is shown, like from the foundation detail, steel frame section, floor, wall, roof, and how the solar panel will be fixed above the roof. The steel frame specification is shown in the tabular column, and the detailed drawing of structural members for floors and walls are also shown. The joinery details for walls and roofs are shown. The tire foundation, like additional to the conventional tire foundation, PCC is laid and the foundation is bolted to it since the structure will be subjected to high wind speed. Also, the roof details are also mentioned. This tabular column lists down the details and specification of the systems that we have used in the site. The PV panels, the type of PV panels we have used, the number of panels we have used, the street light, their specification and water ingress value, rainwater storage tank, their capacity and the number of tanks used, composting toilets, the design of the composting toilet, and the compost pit, the size of the compost pit that we have provided, and the freshwater storage tanks detail. So the list shows the various system and strategies that we have used and how frequently they need to be maintained for better efficiency. So we can see eco coolers, the windows, they all need daily or weekly maintenance to provide more daylight and increase ventilation. And the hand cranked washing machine should be maintained daily so that it is not overloaded. The capacity is 5 kg. And biodigester toilets, the enzymes needs to be taken care, and waste segregation should be done daily. So monthly inspection will be coming for bamboos to check for the cracks or molds or pests in bamboos, and they need to be treated accordingly. And electrical checkups also need to be done monthly. So yearly checkup, the structure of the whole structure should be checked yearly, and the workers also should be trained yearly once to for the good efficient design.
Looking into the instructions and guidelines provided to the workers, their language instructions are provided in their language, which demonstrate how to use the biodigester toilets, hand crank the washing machine, and to effectively carry out proper waste segregation. Coming to waste management, each unit has been provided with separate dustbin, and each block has designated dustbin for waste segregation. Organic waste is collected on the site and treated on the site, as while the recyclable waste is collected twice by municipality. Organic waste management is done inside to vermicomposting, where we have provided 3 pits of size of which holds a size of 1 cubic meter volume for each stage of composting. Coming into innovation, under innovation, one of our goal is to provide a modular construction kit that can be easily assembled by the construction workers. This is a modular panel that we have designed, which includes the section of the wall. The first layer includes a split bamboo of 35 mm with an air cavity, and the next layer is a split bamboo mesh of 5 mm which holds the frame and bamboo with insulation fiber. The next layer is a coir fiber with a 50 mm thickness, and the last layer is a wooden chipboard of 15 mm thickness. This panel is made of locally available material which is able to be assembled easily, reusable and affordable. Coming into roof panel, the roof section includes split bamboo of 80 mm dia and a waterproof layer under it, and with a coir fiber insulation of 40 mm thickness and the bison board of 8 mm thickness. One of our innovation includes eco coolers, which are made of discarded water bottles, which is a sustainable way to reduce an indoor temperature. Prefab toilets with biodigester or a modular solutions for solid waste management and water conservation. Low cost hand cranked washing machine functions with zero electricity and 50% of water savings when compared to the normal condition. When it comes to health and well-being, this project promotes mental health and physical well-being of the occupants by providing open and interactive spaces such as amphitheater and playground, which fosters community engagement. Corridors are provided on the south side of the building, which minimizes solar heat gain into the building, whereas the existing trees that is on the site acts as wind breaks and offers natural comfort in the site. When it comes to indoor ventilation rate and airflow rate, indoor wind speed is recorded around 0.2 to 0.3 meter per second, which is basically achieved through cross ventilation, and this system ensures a comfortable environment for the users. Looking into daylight analysis, about 60% of the space receives natural daylight, which is around 150 lux throughout the year. The corridors and the lower windows provide diffuse light into the space, and also helps in providing the distribution of daylight into the space. Coming into energy performance, the peak energy demand has been reduced from 26.91 kilowatt hour per meter square per year to 17.61 kilowatt hour meter square per year, which is around 35% reduction from the base case. This is basically achieved through envelope efficiency, where the U value has been reduced to 0.57 watt per meter square Kelvin, and other energy efficient strategies such as cross ventilation, stack effect, eco coolers, etc. The solar panel system meets the building energy demand as achieving net zero. The storage battery capacity of 2 days has been provided, which can be used during the disaster period, and the payback period is calculated around 4 to 5 years.
For water performance, our main goals were to achieve 40% reduction in the overall water consumption, treatment of grey water, and use of efficient water resource management. So we have achieved a reduction of 53.8% from the base case by using efficient fixtures such as biotoilet, waterless urinals, aerators, dual flush, etc. And we also have two main sources of water. One is from the municipal water supply, and the other is treated grey water and rainwater from the site. So the gray water is actually accumulated from different sources such as cooking, washing, cleaning, and others. So the gray water treatment goes through a process of phytoremediation, where the collected gray water undergoes a sedimentation and coagulation with water hyacinth coagulant, which is followed by a wetland treatment, after which it is stored in a non-potable water tank. So that can be used for flushing and other purposes as well. And we have achieved up to 80% efficiency through this process. For rainwater harvesting tank, we calculated the capacity of the tank to be 3,500 liters overall. So we have given two different tanks, one of 2,000 liters and one of 1,500 liters capacity. And for the net zero calculation, we have added the overall amount of harvested rainwater, treated grey and black water, and subtracted it from the overall occupant demand, which resulted in a net positive water for about 6 months. And for the rest of the months, we can recycle about 80% of the water that has been used, and we can get 20% from the municipal water as well. So for embodied carbons, we've already talked about the materials that we've used in the design. But in an embodied carbon perspective, we tried to use locally available materials and reused materials inside. So major materials that we used were coir and bamboo, which is available about 50 kilometers radius from the site as well, which reduced the embodied carbon evidently for wall, roof, and floor structures. But for structural unit, we did add more number of materials which did increase the overall embodied carbon for structure alone, but we also had to increase the structural stability. But in overall, we have reduced up to 69% of the embodied carbon when compared to the base case. For resilience, disaster period energy autonomy we have given of about 2 days by a consumption of 118 kilowatt hour, and we have given batteries of 9.6 kilowatt hour, 12 number of batteries has been given. And for water backup, 13,000 liters of potable water for 2 days has also been given. So low U value materials, proper ventilation and planning for climate resilience, and 80% of grey water treatment from the rainwater harvesting also has been provided for water resilience. The site also falls under seismic zone number 2 and cyclone prone zone. So the plinth of 0.45 meter and IS steel sections were provided. Also with the use of simulations from StatPro, we have calculated seismic calamities and cyclone calamities and identified the structure to be stable. For disaster recovery plan, PHC's fire stations material resource shops are found to be around 10 kilometers radius from the site itself.
Moving on to affordability, the project cost is 11,678 per square meter, which is around 47.4% less than the base case, because of the use of material and techniques we have used. For example, the usage of bamboo and the techniques we made with bamboo, and reuse of aluminum corrugated sheets and use of tire foundation. And the construction cost reduced about 59.6%, in which the excavation, door and window construction, wall section, RCC work, all are included. Also, the annual electric bill reduces around 41.6% by the usage of BEE star-rated equipments. Its payback period is 1.12 years. Moving on to value proposition. From the project partner point of view, we have reduced 47.4% project cost and 17.6% reduction in APA and 53.8% reduction in water consumption. Also achieved the modular housing, which increases the productivity and reuse of material. From the construction workers' point of view, indoor temperature maintained within the comfortable range with SDI of 60%, which improves the living condition, provide secure housing and clean water and sanitation facilities. Promote the community neighborhood enhancement with job prospects and skill development and cultural enrichment.
Thank you, and we would finally like to thank our faculty lead, Amalan Kaushik sir, and all our team members for immense effort for about 9 months, and also the jury members for all the comments throughout all the report. Thank you so much.
Thank you. Thank you, team. Let's hear the jury comments. Deepa, I'll start with you.
Thank you for the presentation.
Thank you, ma'am.
It was clear, it was easy to understand what you were trying to explain. I like your component model. How easy was it to build this? And you said construction workers can put this together very easily.
Ma'am,
So
actually, it is
they can
the
be
assembly.
counted.
The assembly process was easy, ma'am,
Okay.
but the weight only was a problem for us because we weren't used to lifting that much about weights also. But the assembly process, we did get it easily done.
Sure. So can you talk about that insulation which is there? How did you, is that ready-made available? How did you go about putting that together?
Ma'am, so basically bamboo and coir, both we sourced from a place called Pandruti, which is 50 kilometers from the site. So that insulation is sourced from the area itself, and it has bamboo fields as well. So we thought since coconut is abundantly available in Kadalur, it will be easy for us to source that material in terms of embodied carbon, and it also reduces energy consumption and gives a good thermal comfort. So that is why we chose with coir material.
Have you compacted it? Like how
Yes,
did you
ma'am.
fit
So
it in?
from the place that we source, they gave rolls, sheets of coir. So they also sell it in bulk, but we had compacted sheets. So that is also given a treatment, and then only we've placed it.
Okay. I think very good effort on that part. I have a comment, observation, maybe you can explain it, where your whole design, there is something about climate responsiveness not very adequately addressed. You spoke about doing all of these orientation exercises and looking at wind flow, and eventually you've come up with the shape that you have come up with, which has units north facing, south facing, east facing, west facing, everywhere. But in your analysis you said what's preferable is not that. Any thoughts on that? How did you end up with this configuration? All the sites. So in case if the wind direction changes in any other site context, so that it acts well on that site also. It's not as simple as saying that I want to fit this anywhere and so I'll give windows and everywhere. That's something that you have to just think about. It's not something you can answer right now. You mentioned there is humidity all around the year. Stack effect doesn't work very effectively when you have a lot of humidity. And in such a humid place, you don't have much delta T between day and night either. So while it's a nice diagram, it won't be as effective as you think it will be. So having bigger openings is a requirement in a highly humid place as compared to attempting a stack where you don't even have a great room height, just like a regular room height. Again, you should go back and review it, or if you have any comment on that.
Also, like we have given 2 windows on the normal sill level itself, ma'am, to encourage cross ventilation. This is the clear story window is just an additional for the hot air to escape outside and to introduce daylight inside the units.
East-west facing units don't seem to have like that. They
They
seem to have
actually
one
2
up
windows.
and one
Yeah,
down.
the central units have 2 windows. The rest of the units have 3, like 2 cross ventilation windows.
And I also find it strange that you don't have external shading on those east and west sort of units, although you have windows.
Yeah.
Again, something to think about.
Yeah, sure.
Lastly, 2 things, but I'll ask only one. There is a problem that you had identified in the beginning, that construction in your case study or initial reviews, that the places that construction workers tend to occupy very unhygienic,
Yes.
right, and poorly, very poor quality in every respect. So specifically when it came to toilets, you've showed photos at how it's not great to use that kind of space. How is your design solving that problem? Do you think your proposal will give them a more hygienic place to inhabit?
Yes, ma'am. We have provided biodigested toilets for them, which is a component module that is already available with the toilet itself. That has an anaerobic its performance. So, and when it comes to the base case, which is exactly available on the site, when it compared to that, they doesn't have a proper door into it. But our design of toilets have provided a segregated, separate space for bathing and a separate space for toilet spaces, which is and we have provided for each floor, so that the construction workers doesn't have to walk too much for going into toilets during night times as well.
Is this easy to maintain? Ma'am, the main problem was in the existing condition, the outlet was not provided properly. Like the outlet was like, it was left on the ground and the water was like flowing around. So here the outlet is actually provided, like connected to proper tanks, which will be actually converted into manures. So the waste is actually segregated properly and it is easy to use also.
Okay, I have few more things, but I'll pass it to Monish, and if we have time, I'll come back.
Hey guys, good job overall, but you picked a very challenging site, so that'll definitely bring in a lot of questions your way. So especially with it's close to the coast, and you have cyclones and storms heavy, and high humidity, right? So these are the main challenges. So you picked. What would have been really interesting in the configuration of the plan, you don't have to answer this, but just food for thought for next, I think that's for everyone, is that in cases like this, when you're giving you such a strong form in the plan, if you can prove that this is the best configuration given these scenarios, you'll make a strong case. Currently, it doesn't come across. Like I said, you don't have to justify it, but I'm just saying, if you can explain why this form is best suited for such a challenging climatic conditions, number one. The second thing is, very small, but again, the roof you use bamboo, I think is not the best. When you have high humidity and high heat, it'll split, creating a lot of waterproofing issues, okay? But the most important thing, which I think at a student level, what we have seen in the last few years, most of you guys are obsessed with tire foundation. A lot of people. And we don't expect our students to get into the detail of the design of the foundation. It's beyond the scope at this stage. So when you're talking to your project partners, ask them what is the kind of foundation and the soil conditions that are there and what is suited for that particular project. That will help you align in the right direction, because in a case where cyclone and storms are there, the role of the foundation is not just to anchor it to the ground. It's the opposite. It should not, when there is extreme winds, the buildings fly off. So it has to be supported and deeper. It could be a pile, it could be whatever. I mean, we are not going to get into the design or the strength of it, but the nature of the foundation is extremely important in cases where the climate plays an extremely important role, like in your case. Got it? So I think just be, because we have seen more than one entry actually going with this tire foundation. Please don't be obsessed with what people have done in the past or other submissions. Try to see whether that fits right for your submission or not. Okay? Apart from that, I think, but the overall work and the amount of effort that you put in the overall presentation is like really nice. Very good to see. But probably I think going forward, you'll learn more in terms of how to approach this. Like I said, it's the site that is the thing that is putting a lot of questions for you. But otherwise, great job.
I was expecting to see the eco-cooler component model. It would have been nice if you had tried to, make it. So it's a good idea.
Thank you, jury members. Thank you, Team Climate Smart. Now let's take a 5-minute short break before starting the next presentations. Our fourth presentation is from Team Anvaya. They have worked on their project Sitara, which is present in Mulchi. So team, you will have 20 minutes to present your work to the jury members. At 15 minutes, I will ring a signal like this. You won't have a 21st minute, which means at 20 minutes, I will stop you and ask you to end your presentation.
Yes,
After that, you will have 10 minutes for your Q&A. Okay, team, the stage is yours.
Good afternoon to one and all present here. I'm Master Manas Gaudi, student lead of Team Anvaya. A bunch of students from architecture and engineering have come up with a proposal for construction worker housing. And this is my friend Anvaya. Anvaya, where are you? Hello?
Thank you everyone for waiting. Now Team Anvaya will start their presentation.
Good afternoon to one and all present here. I'm Master Manas Gowde, team lead of Team Anvaya, a team of architecture and engineering students who have come together to put down a proposal for the construction workers' housing in Bhugaon. And this is my friend Anvaya.
Hey Manas and team, this place looks new. Where are we?
Hey Anvaya, we are at the divisional jury at Mysore Infosys campus. And actually, since you were interested in the project, I was wondering, would you like to introduce the jury panel to the...
Sure Manas, I would love to. They build the cities we live in, brick by brick, beam by beam. Yet, when the day's work ends, where do they return? Without construction workers, there is no skyline, no roads, no bridges, no homes. They are the foundation of the construction industry, essential to every building type, be it residential, commercial, institutional, or industrial. Despite shaping the built environment, their own living conditions remain the most overlooked. For these reasons, we chose to focus on construction worker housing to bring attention, innovation, and dignity to the very people who make every other structure possible. Introducing Team Anvaya, a group of 17 passionate innovators from BMS College of Architecture and BMS College of Engineering, coming together to reimagine construction worker housing for the Solar Decathlon India competition, where sustainability meets social impact. We present to you Sthira, a net zero sustainable housing initiative for construction workers in Bhugaon, Pune. More than just housing, it's a promise of safety, autonomy, and a sense of belonging for the very hands that build our cities. Sthira stands on 4 key pillars: housing, recreation, childcare, and culture. We've developed Sthira through meaningful collaborations with Center for Green Building Materials and Technology, Inca Studios, Make Them Smile Foundation, and TBF Environmental Solutions, who brought ground-level insights into real-world implementation. Our knowledge partners, Center for Sustainable Technologies, Indian Institute of Science, and Institute of Wood Science and Technology, Bengaluru, provided critical support in sustainable design and material innovation. Our project partners set clear goals for this vision: to accommodate 800 workers, provide one toilet for every 10 people, and one bathing unit for every 20, all within a sustainable net zero development that redefines what worker housing can be.
Moving on to the context of the project, our site lies in Bhugaon near Pune, Maharashtra, and it is being developed as a 3-phase project where the first one is the sales office, the second one being the site for the labor colony, and the third one being the Rohan Saroha itself, which is a residential development. We conducted preliminary analysis of the climate and found out that our site is experiencing maximum winds from west and southwest. This is the windrows diagram. We also conducted a sun path analysis to find out the shade, shadow, and the number of sun hours that our site received. We conducted a slope analysis, and with the slope towards the west, we have a beautiful view to the west valley, which is full of cosmos flowers and lush greenery. Making a preliminary analysis on the needs of the project of the stakeholders, and a statistical analysis on the marriage ratio, the types of families, skill ratio, and state of origin, we got insights into what our program should look like. And we devised with 4 different types of livings, being the couple housing, the family housing, bachelors of 6 sharing, and bachelors of 12 sharing. Moving into the design, my team member Nandita will explain.
Yes, so as Anvaya mentioned, we are designing for 800 occupants in an area of 2,700 square meter. That's a G+3 modular design. Now coming to the design development, first we extruded our site to use it to its complete potentiality and given 2 main axes that acts as sight lines as well as guiding aspects. Then we've carved out voids from the mass to give open breathable spaces and zoned the spaces according to the function, and then finally arranged them according to the wind direction and the sun path. Now coming to the zoning, the major chunks, that's the bachelor housing, takes up the western side, and the family towards the north, and the couple housing towards the south. Toilets kept towards the road. And now we see the ground floor and the first floor are both public and private, as they have both public and private amenities, where the second and third floor is completely residential, that's again private. The zone 1 that talks about the public amenities has a creche, grocery, healthcare, and other services like the electric room, record room, and the washrooms. The
creche has its own playground that expands to the central congregation space. The zone 2, that's the couple housing and the dining, is both connected internally for easier circulation. And then towards the south, we have the washroom, diverting the odor out of the site. The third zone, that's the bachelor housing and the family housing, has the larger courtyard with majority of activities happening there. Towards the south, we have a family housing with the courtyard facing towards the western side and taking advantage of the view. The windows of the bachelor housing are facing towards the west to capture the wind, also the view. And towards the south, the courtyard of the family housing has a percolation pit that also acts as seating space. The first floor is arranged in such a way that all the entrances and exits look into the central courtyard. And the first floor also has public amenities like the dining, creche, and washrooms. The second floor, majorly being residential, has a lot of family units. And the third floor, comparatively with a lesser density than the second floor for structural stability, and also has a lot of terrace spaces and open spaces. The roof, taken to its maximum utility, has been incorporated with solar panels and overhead water tanks. As we see, these courtyards play a very important role in the life of construction workers. The courtyards transform throughout the year into different spaces with different activities. Our landscaping is not permanent, but a temporary productive landscape where we incorporated old tank planters, hanging planters, water percolation pits, tire sitting, all of these keeping the space very much engaged and active. Finally, coming to our individual unit model, the smallest model that we have proposed is a 2.8 by 2.8 meter couple housing with one double bed and compact efficient circulation space. The family that is double the couple housing with 4 occupancy has a double bunk bed and a space where kids could go around. Bachelor housing, where we have prioritized occupancy over privacy, hosts around 12 people with 6 bunk beds and also has a convertible window balcony for increasing natural ventilation. Now Prajwal will continue on the construction.
Considering the various demands of the project, we formulated a set of objectives for the project's construction to follow. We intended the design to be a scalable module that can be replicated at an economical rate without compromising on the quality. The team also ensured that the construction of this project can take place within an average time of 2 to 3 months with minimal intervention to the site. For the structural system, we have designed a modular steel frame of area 5.6 by 5.6 meter and height 2.8 meter. The fundamental unit of each module is a hollow square steel pipe of cross-section 60 by 60 mm and gauge 4 mm. These pipes also happen to be the most commonly used materials in the existing labor colonies of our project partner, Rohan Builders. The primary structure element consists of 4 such pipes which are bolted together, and a secondary structural element consists of an individual pipe. We have also proposed for custom-made joineries, which are going to be used to join all the primary structural elements together, forming a 3-dimensional lattice. Around 70% of the entire steel required for this project is going to be repurposed from the existing labor colonies of the recently completed projects of Rohan, as well as the scrap dealers, which our project partner is in association with. Each module consists of a walling system and a flooring system. The walling system consists of 2 types of panels: a 75 mm thick composite panel made of bamboo mat, basalt rock wool, and banana organic waste for the exterior, and a 25 mm thick banana organic waste panel for the interior. The flooring panel consists of a 40 mm thick construction and demolition waste panel, which is further reinforced with a steel mesh. All these panels have been right-sized in order to maintain structural integrity, as well as coated with a mixture of hydraulic lime and cow dung to make them resistant to fire and water. As you can see in the section, this tilted module lies on a 100 mm thick foundation of construction and demolition waste, and this has been done owing to the site's high soil bearing capacity of 100 ton per square meter. We've also conducted a load simulation analysis of an individual module as well as of the entire structure in order to prove that the project is feasible, and the results proved us that the structure is structurally integral. The construction of the project begins with the excavation of the site, followed by the setting up of the footing. And once this has been complete, we install the columns to the foundation. Proceeding with this, we install the primary structural elements and the secondary structural elements, forming a modular frame. Once the modular frame has been ready, we set up the flooring panels made of construction and demolition waste. This is followed by the installation of the walling system made of banana organic waste. Finally, we set up the fixtures and the fenestration into the module, bringing its construction to a completion. In order to aid ventilation and daylighting, we have provided for convertible balconies on selective modules of the project. These modules have been selected on the basis of their potential for views and ventilation. The balconies are going to be made of bamboo, steel, and GI wires, and they've also undergone a load analysis test in order to prove that they're structurally stable. For our project, we have innovated two materials. One is a banana organic waste panel, which is going to be made from the surplus organic waste produced in the banana plantations of Maharashtra. And the other one is a construction and demolition waste produced from the construction waste sourced in and around Pune. The project's formulation has been so done that it caters to the physical, mental, and social well-being of the users. In order to ensure the physical comfort of the users, we have incorporated passive design strategies. These passive design strategies include the inclusion of courtyards to ensure cross-ventilation, the creation of voids and staggers in order to ensure stack effect and venturi effect, and the provision of landscape to create green, cool zones. We've also capitalized on the use of materials as well as the mutual shading of buildings to further increase the thermal comfort of the building. To justify the use of the passive design strategies we have incorporated, we have conducted a number of simulations. The results of these simulations state that we have achieved an internal air temperature between 16.5 degrees Celsius and 20.5 degrees Celsius, a spatial daylight autonomy of 58 to 60%, an annual sunlight exposure of 9%, and an annual illuminance between 2,000 and 5,100 hours. The culmination of all these simulations state that we have achieved 85.9% of comfortable hours annually. To cater to the mental and the social well-being of the users, we've also strategically provided for congregation spaces within the site to ensure socialization among the users. We now have Rohan in order to talk about the performance of the building.
Good afternoon, respected panel members. I'll be taking you through the building performance of a model which involves 4 core components. Starting off with energy performance. Energy performance has 2 objectives as far as our model was concerned. That was to reduce our EPI factor of the model and to improve our energy generation. So the baseline EPI for a model of our scale was 33.56, which through 5 crucial strategies we were able to bring it down to 17.58, effecting a reduction of 48%. Then we were able to effect this across 3 different categories of loads: lighting, ventilation, and equipment loads. So the first strategy that we worked on was form and orientation. So in form and orientation, we played around with the shoebox model of our design to orient it in a way that we could reduce our EPI, finally arriving at 12 degrees of site alignment, 12 degrees site alignment coming to 29.7 of EPI factor. Then we played around with the window wall ratio iteratively, falling on 20%, giving us a site alignment, giving us an EPI factor of 27.6, effective 18% reduction. Later, we played around with the building envelope using materials like banana organic waste panels, C&D flooring, lime plaster, and cow dung, giving us an effective EPI of 21.8. The fourth strategy that we used was comfort and design, like passive strategies, where we played around with the orientation, the venturi gaps, and the layout of the model, arriving at a staggered and courtyard integrated model, giving us a 19.8 effective EPI. And we also incorporated optimization of shading devices by using deep overhangs, arriving at a final EPI of 17.5, effective 48% reduction. Now let's look at the internal energy generation. Solar energy gave us about 96.4%, amounting up to 106,000 kilowatt hours of energy across 2 types of panels. Later we also incorporated wind energy, giving us about 3.7%, 3.6% at 3,700 kilowatt hours of energy. All of this was incorporated in a smart grid system which combined 3 sources of energy and fed it to a 15 kilowatt inverter, which was then distributed through a main and sub-distribution boards for our various loading requirements, and the surplus of which was fed back to the municipal board. Now, in water performance, the baseline water requirement per person is 135 liters per day, and through our strategies, we were able to bring it down to 60.5, affecting a 55% reduction. This shows the breakdown of our water generation, consumption, and treatment and so on. We were able to treat close to 12,500 kiloliters of grey water, 2,500 kiloliters of black water, and give up to 12,000 kiloliters of groundwater recharge. These are the 4 strategies that we used. The biochar filtration system was exclusively used for grey water treatment. The ultra-low flow fixtures were used for reduction of water consumption. Rainwater harvesting filter and the nanofiltration process were used for purifying rainwater before using it. Using these methods, we were able to increase the rainwater percentage from 7% to 15%, arriving at a net positive water cycle status for our project. Now, waste management objectives, we were able to stream our waste collected in 3 different types: dry, wet, and on-site recyclable wastes. But the star of the waste management strategies was the Tiger biofilter, which was given to us by TBF Environment Solutions. This was exclusively used for treatment of black water, where we were able to arrive at an odor-free, clean, and cost-effective, low-energy consumption solution to treat the internal black water that was generated. Carbon emission affecting implementing our plan allows us to reduce embodied carbon by 97.7% from the baseline value of 310.7 to 6.9. We incorporated 72% reused steel, C&D panels, lightweight bamboo, and organic material to arrive to be able to affect this. And now we look at the resilience factor of the project, which will be taken over by Manas.
Yes. So in order to make our building resilient from heavy rainfall, soil erosion, earthquake, fire hazard, and pollution, we have incorporated strategies like using old cement bags as retaining walls over here in this portion, and using landscape to hold soil. We have used tilts, and also we have waterproofed and fireproofed the materials that we are using in our construction. We have achieved an water autonomy of 4 days and energy autonomy of 3 days. Moving on to the conclusion and why it makes sense to invest in our particular project. We were able to reduce the baseline estimate from 11,600 rupees to a proposed estimate of 9,253 rupees per square meter, which is significant, which stems from mostly being able to use the 70% recycle, approximately 70% reused steel, and incorporating innovative materials instead of the industry standards. Yeah. So what is in it in our project for the project partners? Modular design, high density planning. These both incorporated will allow our project to be a prototype that can be put up in any different site possible with reduced cost, easier scalability, and construction. The high density planning allows for 800 people to be accommodated in a very small site of 2,700 square meters, which allows for being able to cater to more number of people while not compromising on user experience. There is a view from the sales office, the mock-up rooms, into our site. So when a potential customer comes there to buy the flats, we aim for them to see the very hands that are building the houses, and that builds an empathy. So yeah, we have innovated materials like the BOW composite panels, which are 100% upcycle waste. We have innovated construction and demolition waste panels, which lowers the carbon emissions. And moving on to what is in it for the workers. We have provided terrace and relaxing spaces, so after their very hard day, they can come and sit here in an evening. We have also provided amenities like grocery store, healthcare, sanitation, creche area, community zones like OAT that my friend mentioned earlier, which help in their mental well-being. Right, so we have also incorporated NGO-aided workshops with Make Them Smile Foundation and EduVan, which will help in upskilling of the workers and also for mental well-being. We have innovated a site called SiteSync, which is for project resource management. We were able to talk with the on-site realities, and we got to know what were the issues. If India is going digital, why not us? These are certain goals that we were able to achieve in a contest like waste management, water management, energy performance, embodied carbon, affordability, and health and well-being. Thank you so much.
Thank you, team. Now let's hear the jury comments. Monish, I'll start with you.
Great presentation. Good work. What I really like about your presentation is that your density and the zoning is really spot on. any developer would love to see this kind of density because that brings him the biggest ROI on the project. So I think that full score on that, I think that is great. And also in terms of the spaces, you spoke about the views, and which is also very important for the construction workers. It's not just the space, and also the greens in between. And but what would have added with this density, a more compelling case, is daylighting analysis, which would have been quantitative, because that with this density is missing. Currently, like especially the lower floors, are they getting good daylighting or not, is not pretty clear in the presentation. But you can counter argue it by stating that during the day, most of the time, the construction workers will be at site. But I'm giving an answer way out. But the thing is, as part of SDI, we also want you guys to learn. I mean, we can always, in terms of how to quantify the spaces that you're talking about. Like I said, the density is fantastic, right? So we can get back to that. But what I don't like in the presentation is, while the density is amazing, the beds, 12 beds, very similar to a bus. If you've taken a shared bus journey where the beds are like 4 of them are stacked together, might not be the right environment. Had it been, if you reduced, or the bedding configuration could have been different. Very small thing, but like I said, that would have been better in terms of the spatial quality. Okay, but these are not the major concerns so far. There are 2 assumptions that you made in the design, which has, you said 97.7% reduction in the embodied carbon. That's a huge undertaking. And this is based on 2 assumptions. One is, you're saying 129 tons of steel is being supplied as recycled steel by the Rohan developers. Do you have any proof, or you did mention that the other sites where you're getting it from, because that's huge. Anyone having that amount of steel would be not leaving it, and that too the same kind of steel. That's a huge undertaking. So I don't know whether you have any proof for that or not, but even more, what you say, another assumption that is pretty much strong is the C&D panels that you're using for the flooring, which is 5 feet by 5 feet, 40 thickness with reinforced. You did mention about the steel as the reinforcement in that. Is if you can actually make this work this way, this can revolutionize the industry. 40 panels for flooring, which is 5 feet by 5 feet, if it can take the structural support for the C&D panels on the floor. Because these are the 2 contributing to reducing your embodied carbon quite a lot. So the rest of the things are pretty this thing, but full marks on the innovation in the materials and the panels that you used, and the balconies and all. Great job. I mean, overall, it's an amazing presentation, good work. But these 2 things, I think, even if you don't answer the others, it's okay, daylighting and all that, but the steel and the C&D panels.
Yeah. So for the use of steel, we consulted with our project partners, and this is a system which they already have. They have the system of reusing their steel modules from one labor colony to another labor colony. So the reason we zeroed in on the percentage as 70 is because, according to their analysis and according to their study, after every life cycle, once the labor colonies are shifted, around 70% of the steel which they have can be reused. The others fail the structural test. So they have a certain set of tests which they conduct in order to prove that this steel can be reused and repurposed again. And apart from that, they also have a lot of maintenance, such as provision of oil coating, in order to make them corrosion and weather resistant. So that's the reason we set on 70% as the number. But in case the affordability has been done in such a way that even if instead of 70%, say we get 50% of the steel which we require, we are still within the baseline estimate of 11,200. So that's about the steel. And about the construction and demolition waste panels. So the size of the panel is 700 by 700 which is around 2.5 feet by 2.5 feet. I think in the report there was
a 1400 by 1400 in the report.
We have corrected it, we have rectified it, and also we have given an additional reinforcement of a steel mesh. So we worked with Center for Sustainable Technologies in IISc, and after consulting the professors over there, we came up with this new right sizing size of the panel, as well as the added reinforcement to make sure that they're structurally stable.
Okay, but still, like I said, that's a great possibility if it really works that way, because I think since this is what is creating the affordability and also the embodied carbon reduction,
yes,
the data on both the things, because you're saying 97.7, that's a huge statement that you're making. If you can show some pictures to say that, and I mean, I'm not saying in general, I don't think you can take it out right now, but this material and also for the C&D panels, like more research on that, because that is going to, if it actually works this way, that's going to revolutionize the industry, especially the flooring, the floor slabs. Okay.
That was an excellent presentation. The way you started, through and through, you held the thread, very well laid out, the content, the quality of graphics. Your component model is really, really good. And while there are some questions, I want you to actually help us understand this biggest model that you've brought. If you can just help us explain what you have done here.
Due to the size constraints, we had to cut it down to get it in. Yeah, so this would be a foldable, that's the railing. So it'll be folded back and put like this. So that will become the sill of the window, the sill height. Yeah.
You have made a working model, right?
Yes.
Yeah. Now it becomes the wall.
Yes. This is the window. I'm so sorry, it's a prototype. That's
No, it's fine. It's fine. It gives a good.
And that's the frame. So you'll have another window that can be opened up.
Right. Right. I'm curious to know, what did your project partner say, looking at it, or they haven't yet seen it?
No, ma'am. We did show them this. We didn't show them the prototype. We showed them their intention and the design of it. They're quite happy because most of the construction worker housing is done on a needly basis. They do not provide an element of luxury as such. So they were quite interested that we have tried to incorporate such a luxurious element, if I may say, to even construction worker housing, and that we have done it so that there's potential for views and ventilation as well.
Have you seen the whole presentation?
Sorry, sir?
Have you seen the whole presentation that you made?
Not this presentation, but the reports.
But the reports there.
Yes.
It actually caters to one of the avitas also. So as you see, most of the bachelor units are around these two courtyards. So adding these elements into those made the maximum sense. Now you have got this in the accommodation of the bachelors where 12 people sitting, and it's just a good place.
One minor point. Your toilets, they don't work because you have taken everything on the sides. It's very difficult for people to walk during the day in an emergency when it rains and all that. So minor, nothing major, but it should be more spread out, the toilet.
Yeah, we also have, two of them are set towards the road. One toilet block is set towards the bachelor housing, towards the rear side.
Yeah,
We've
so
got
basically
that
they're just tucked away. That's the point. Okay, why couldn't this balcony be fixed? Why this open and close? So this element is in all your units?
The ones?
No, ma'am. It's been provided to the modules which have a great potential for view and ventilation only. So these are selective modules. It's not depending upon typology. It's not depending upon the block it is placed in. It's based solely on if there's a potential for views and ventilation.
Okay. Another question I had was same thing about the steel that you're going to repurpose. The size that you have proposed, is that the size that you generally get?
Ma'am, the size of the elements which we have designed has been done so that it's compliant to what our project partner uses. A project partner uses a steel pipe of 60 by 60 mm. So we have used that as the element to design our element. Like our element consists of 4 such of pipes which are bolted together. So the primary elements are such design that they're compliant to what a project partner is using.
So the size does come from them,
yes.
right? What is available?
Yes.
Okay. Another question I had was the the banana boards that you're using. Can it take impact the units on the ground floor?
Yes. Although it's not a readily available product in the market, this is something which has been experimented with. So we have an industry called the EcoBoard Industries who practice something similar. They produce biomass panels with general organic waste, but we have experimented with banana organic waste to be specific. So we have it's incorporated with banana fibers, sawdust, and resin to make it structurally stable.
Structurally stable, yes, but it's a thin material. So that's something to think about, that for the ground floor units, you may need something which can take impact, right? So if you want to have a different wall section using the same material but on the ground floor, whereas compared to the top floor and so on.
Deepa,
yeah.
I'm so sorry, but we have to cut you short.
You said we are doing well on time. Okay, I'm kidding. Thank you. I also want to say great job with exploring the materials that you have done. Very good work. Yeah.
Thank you, ma'am.
So thank you, Team Anvaya. We will now take a long break for lunch. We will start the presentation for Team Stran at 2:30 p.m. Folks online, stay tuned.
Solar Decathlon, India, what's it all about? Net zero building, what's that all about? Solar Decathlon, India, what's it all about? Net zero building, what's that all about? Is it cool? Is it hot? Is it drool? Is it fat? What's that all about? Real world problems need innovative solutions. If you don't act now, there will be implications. Is it hot? Is it cool? Global warming would be cruel. You will form a team with the same desire, going for the moonshot, forged by fire. We use technologies and crazy simulations. We learn to design with new innovations. So what you waiting for? No procrastination. Get off your butt, come join our workstation. Solar Decathlon, India, what's it all about? Net zero building, what's that all about? These problems are tough and complex too. Your partners are there to help you get through. This challenge is exhausting, intense, it's a drill. These 10 mad contests will sharpen your skills. Net zero energy, water and stuff. And affordable too, that's crazy enough. Solar Decathlon, and your heck, it's really tough. But your attitude and grit is more than enough. Get your hands dirty on real world projects. You're gonna learn more than your specialized subjects. Solar Decathlon, India, what's it all about? Net zero building, what's that all about? Cutting edge, butting edge, climate wedge, make a pledge. Do it all, save it for a lonely planet after all. Understand, climate friend, take a stand, make a trend. In the end, recommend your ideas will help defend. Are you hot? Are you cool? Are you gonna be a fool? Zero heroes are here to stay. So what you waiting for? Come join this play. Net zero building, that's what it's about. Solar Decathlon, India, that's what it's about. SDI.
Pick a site on a railway track. Put your building on an earthquake crack. Cutting million trees and planting roads and houses with their electrical loads. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Put your building facing west. Make a toast of every guest. Concrete, steel, here and there. Carbon emissions to poison the air. Dumb ways to build, so many shafts that taper down, bad staircase trip over your gown. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Start building with no hard hat, walk barefoot, toes go splat. No gloves on, no goggles too. I wonder what these wires do. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Building on a melting glacier or a floodplain, letting all your rainwater run down the drain. Heat the earth enough to fry eggs on the sidewalk, with homes that must have ACs always running. These mistakes we make are all avoidable, and that is why we must let go of these dumb ways to build. Dumb ways to build. Dumb ways to build. So many dumb ways to build.
Build less, build smart. A message from Solar Decathlon India.
The world is so hot, hot,
Hello everyone, welcome back to the Construction Worker Housing Division. We will now continue with our presentations. Our fifth presentation is from Team Stran. They have worked on a project. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal like this. You won't have a 21st minute, which means at 20 minutes, I will stop you and ask you to end your presentation. After that, we will have a 10 minutes question and answer session. Please keep your answers direct and to the point. Okay, team, the stage is yours.
Good afternoon, jurors, fellow participants, and audience members. We are Team Stran, here with our proposal for a modular solution to construction workers' housing. In the corners of our growing cities, millions of construction workers live in the shadows of the structures they build. Why do we need better housing for them? Over 85% of these workers lack access to basic amenities like clean drinking water, safe toilets, and reliable electricity. In cramped, unsafe conditions, they face the constant threats of diseases, injuries, and displacement. This is where we step in. A vision of 10, Team Stran is a multidisciplinary team consisting of students of architecture and engineering from BMS School of Architecture and BMS IT, with Century Real Estate as a project partner, and with the support of our industry partners, Bamboo Pecker, Re-Eartham, and EcoSoch. Our approach is simple. We plan to balance the needs of all our stakeholders and to shift the narrative from temporary housing as an afterthought to a replicable system that respects life and labor. Our proposed site is 300 meters away from Century's project Regalia, situated in Indiranagar in Bangalore's composite climatic zone. The site area is 2,750 square meters, which allows a ground coverage of 50% and has an FAR of 2. The site has 3 main accesses with tree buffer on the north and west. This leaves the rest of the site under direct solar radiation. The predominant wind direction is from southwest to northeast. Our project partners' requirements consisted of accommodation of up to 300 workers, a common dining area, a shop, medical room, and other requirements as per labor laws. From our on-site studies, we understood the age and work culture of the workers and understood the clear social work-based hierarchies present in these groups. This led us to develop the master plan in the form of mohallas. These are courtyard-centric clusters tailored to the social and functional needs of the workers. The whole site is divided into 3 mohallas, with bachelor mohallas placed on the lower end of the site and families on the northwest. The entrance from the south leads to the shop and the security cabin. For passive surveillance and ease of access to facilities, the family units are placed towards the northwest. The dining acts as an anchor by being a multipurpose space. All the services are aligned towards the northeast according to the wind direction.
We explored 3 iterations while focusing on ease of deployment and transport. We finalized on option 3 that gave us 3.5 square meters per person. A conscious effort was made to arrange these modules to reduce solar heat gain and enhance natural ventilation through passive strategies such as mutual shading as well as orientation of buildings, of the openings, pardon. Introducing the Stran module, a compact and collapsible 3 by 4.5 meter structure weighing only 1.2 tons. The on-site assembly process has only 4 simple steps. The flat-packed module has a total height of just 0.98 meters with all its essential components that include the doors, the windows, the side panels, as well as the chajja, all tucked in within the module. This module can be unfolded with the help of cranes, aided with our own custom engineered hinges that facilitate smooth movement. In collaboration with our industry partner Bamboo Pecker, we have designed a bamboo staircase to access the upper modules. We've used 80 to 100 mm dia bamboo for supports, whereas we've used 40 to 60 mm dia bamboo for the threads. We've also placed extra stringers and cleats for added stability. We've also collaborated with Re-Eartham Recycled Bricks that has an embodied carbon of just 0.9 kg CO2 emissions that uses waste PPE kits, waste paper, as well as eco-binder. The novel bed project by Re-Eartham features a bed base made of recycled PPE kits, whereas the coconut coir mattress is our own addition.
The single unit design accommodates 4 people with an integrated bed. The overall structure frame is consisted of hollow steel frameworks in which we have considered 91.5 into 91.5 mm for the column sections, whereas 91.5 into 121 mm for the beam sections. When you're looking at the roof paneling and the wall paneling, we have used 8 mm thick Rycron panel with an insulation of coconut coir for thermal comfort, as well as for the flooring, we have used around 12 mm thick Rycron panel, which is supported by recycled steel framework. The overall module sits on a Re-Eartham brick plinth, in which it has a compressive strength of 1200 kg per centimeter square. Other features included are the WPC framed window as well as 12 mm thick Rycron for the door panel. For the waterproofing, we have considered 20 mm thick gasket and sealant securing the connection between T sections as well as Rycron panel. For the foundation, we have used 100 mm thick concrete bed as well as W and C and D waste as infill. When you're looking at the closed module, the overall hinged column folds down and sits at the integrated bed, transferring the overall top portion load to the bottom portion. The modular nature of the module helps us in customization of various window configuration. You can see we can have a clear story windows, ribbon windows, full-length glass pans, as well as skylights. It is depending on the site context or the requirement of the stakeholder. The hinge being the most critical component of the Srijan module, enabling its collapsibility as well as structural integrity. To enable this folding, we have divided the column into 3 segments, in which we have designed 2 types of hinges, one for the top portion and another for the middle portion. When you're looking at the top hinge, which is located at the junction of the top roof frame and the vertical column, it comprises of 2 major components. That is the L angle, which is welded at the vertical column, whereas it has a pivot movement with the help of a rod on the beam section. When you're looking at the middle hinge part, we have used 2 hollow sections that are welded towards the vertical portion, and for movement and pivot structural stability, we have again added flat plates. A structural analysis was conducted to test the resilience of the frame as well as hinge under load conditions. This figure shows that it has a maximum displacement of 2.936 mm, showcasing that it can take up to a load of 500 kgs. When you're looking at the compacted form, it shows a maximum displacement of 0.98 mm, showcasing that it can resist load even in its compacted form. Over all this calculation, we came to a solution that the overall module can take up to a load of 4.5 tons with a factor of safety of 3. The dining area, which is of 18 into 9 meter, is a permanent open pavilion, which has a primary framework of bamboo, in which we have used 2 types of bamboos, that is bamboo bambosa and bamboo balcova. Bamboo balcova has been used in the beam and column section of 100 mm dia, whereas for the purlins, we have used bambosa bamboos. To anchor this overall structure, we have used circular steel sections of 80 mm dia, which has a foundation of 1200 into 600 into 600 mm. For the roofing, we have again considered a corrugated sheet made of Rycron, which has a 5 mm thickness, which is topped by solar panels for energy generation. Additional features included are the flattened bamboo shading devices, also known as chikjali, and electrical service lot for energy.
There's a 65% reduction in embodied carbon in the proposed case when compared to the baseline. The embodied carbon drops from 551.9 to 193.4 kg CO2 emissions per functional unit, with flooring and walls having major reductions. and underlining the effectiveness of material substitution and reuse. The panel detail showcases the building envelope comprising of coconut coir insulation and Rycron panel, offering good thermal performance with a U value of 0.21 and 0.25 watt per meter Kelvin respectively. Coconut coir, being a natural insulator, has a negative carbon emission factor of minus 1.1. The chart outlines low embodied carbon choices across all building components. For instance, recycled steel joineries and WPC windows further lower the structure's embodied carbon footprint. The team has achieved a 33% reduction in EPI, reducing it from base case of 27.55 to 18.26 kWh per meter square per year through a combination of active and passive strategies. Active strategies includes installation of 72 solar panels above the dining area, which generates up to 148 kilowatt hours daily at peak with the support of a 50 kilowatt hour battery. The diagram shows a conceptual distribution of energy generation across various loads and their supply through the solar PV panels. Active strategies also include optimizing the electrical wiring system by integrating an overhead service loft in the dining area and using industrial connectors in the modules. This minimizes the cable length by 261 meters and reduces transmission losses. Passive strategies include envelope efficiency, cross-ventilation, and optimum building orientation. The building envelope has a U value of 0.205 watt per meter Kelvin, offering good thermal insulation, thereby reducing heat gain and cooling loads. The buildings are oriented in the north-south axis, providing mutual shading. The door and windows are placed opposite to each other, enabling cross-ventilation. This shows the electrical layout, showcasing module connections. The electrical wiring is integrated into the lower half of the structure to enable folding, and industrial connectors are connected on the shorter end. The dining also has a chemical earthing system to safely dissipate excess energy, which cannot be stored by the batteries.
The project's primary source of fresh water is water tankers, which provide 45,000 liters of water on the first day. The project has 3 treatment and recycling channels, which include grey water recycling, black water recycling, and RO reject water recycling. All of these, combined with the introduction of low flow fixtures, add to the efficiency of the system. These have made us achieve a reduction in our overall consumption by 49.06%, and has made our secondary consumption come down to 24,412 liters, which is only sourced for bathing, hand washing, and RO purification water. And our total per capita demand has also gone down from 135 liters to 68.76 liters. The plumbing layout showcases the flow of fresh water through the pipes, where 2 gate valves have been provided, one towards the bathrooms and the second towards the toilets, which can be operated as per requirements. The toilet module consists of recycled MS L-angle sections, which has WPC panels for walling and flooring, with a 5 mm corrugated Rycron sheet as roof. The sectional diagram shows the flow of water through the site, with the sump of a capacity of 30,500 liters pumping the water up to 2 OHT tanks of 10,000 liters capacity each. The black water collected from the toilets as well as the kitchen is transferred to the biodigester, followed by the STP, which after treatment can be reused in the washrooms for flushing. Grey water collected from the bathroom is sent to the dewatch system, after which it can be used for irrigation and housekeeping. The sketches on the top represent the conceptual working of each of these systems.
Coming to resilience, water self-sufficiency is achieved through a combination of RO reject water reuse, STP treated water for washrooms, and dewatch treated water for secondary purposes, enabling the system to meet the daily demand for up to 3.5 days. Electricity backup during emergencies is covered by solar panels and 50 kilowatt hour battery, covering all essential loads for approximately 3.5 days during low efficiency solar output. Resilience is enhanced through dedicated fire escape routes and assembly points, ensuring safe evacuation. CCTV surveillance adds a layer of security and real-time monitoring across the site.
A safe space is a healing space. Thermal simulations showed that the module interiors maintain an average of 23.5 degrees Celsius year-round, very close to the thermal comfort benchmark of 24 degrees Celsius. The beds are placed in the cooler corner zones to enhance occupant comfort, whereas the fans are located in the center to mitigate localized heat buildup. The spatial daylight autonomy shows that spaces receive optimal daylight around 600 to 1400 hours annually, thereby reducing the need of artificial lighting during the day. Outdoor wind analysis shows that the internal corridors stay cooler than the outside, thereby promoting social interaction and sitting zones, while also moving away foul air away from the site. The landscape design integrates herb gardens that promote community interaction and mental well-being. We have also lined the corridors with trees, as well as the green buffer zones provide for a calmer environment. And yes, coming to the cow dung flooring pathways, which uses a layer of cow dung slurry that reduces heat gain, as well as acting as mosquito repellents.
Though the initial capital investment in the proposed case is 1% higher than the baseline, the team has achieved a 35% reduction in utility cost. This is due to the modular nature of the project, which does not require frequent installation and has a lifespan of 3 to 4 projects. This reduces procurement and loss of raw materials like cement by over 13% for every installation. Another method used is the conversion of energy and water reductions into valuations. A 49% reduction in freshwater demand is equivalent to a 50% reduction in water bills. Similarly, usage of solar panels over 5 years is equivalent to those electricity bills and DG rental in base case, after which the energy generated from the solar panels is fundamentally void of any cost. This has led the team to have a 47% reduction in life cycle costing over a span of 20 years, reducing it from 127 million INR to 67 million INR. Our project has a comprehensive value proposition for both its project partners and users. For project partners, there is cost reduction from the reduction in water and energy consumption, which leads to 47% and 50% reduction in bills respectively. Ease of transportation due to the modular nature of the structure, which is compatible with all HMVs. Opportunity to expand beyond the construction industry due to its versatility and modular customization options. Time-saving aspect has also been looked into, which requires per module only 4 hours for assembly and 3 hours for dismantling. This means 90 modules can be assembled in the span of 1.5 days, which is a 60% reduction from conventional methods which require 7 to 10 days. A proposed business model puts the module priced at 75,000 each, which includes the warehouse costs and a profit margin of 13%. Possible rental scheme has the module priced at 5,000 rupees INR and has a payback period of 15 months. For users, there is inclusion of family units, safe community spaces, compliance to health and safety norms, and privacy.
As a wise man once said, the true measure of a society's progress is how it treats its most vulnerable. These visuals capture our intent and design, showcasing our priority towards community, health, and mental well-being. Now, we would like to demonstrate our 1:5 scale model.
So the side panels come off and can be stored within the module, after which you can use the custom-made hinges to collapse it. The beds which are part of the integrated system take some of the load and transfer it to the lower part of the recycled steam framework, so there's no load on the flooring itself. Thank you.
Yeah. Thank you, team. Let's hear, let's hear the jury's comments. Deepa, I'll start with you.
Good presentation teams, clear and very good graphics as well, and great job in making this component as a working model as well. I thought as an idea, this has great potential in how you've explored the modularity in a different way. It's not dismantling, but really picking it up and putting it in like a shipping container in a way. So that is something I think there's a lot of potential in this idea. Few things I thought which is maybe question, comment, and you can see how you want to respond. Is there a reason in your site layout you have the restrooms and everything tucked away in one side and it's not really distributed?
Ma'am, we wanted the service code to be towards one area because that reduced our piping which came into the modules itself. So if we divide it into two areas, the lines running to the DWATs and everything.
Can you pull that up?
Hello? Yeah.
Yeah, so accessibility of at least the washrooms from somebody who is like on the bottom corner, is that something you thought about? Like, isn't it like far away?
So ma'am, no, it's not that far away. It's about from here to there, it's about 25 meters, that's it max.
Also, we placed it there so that the family units get an advantage wherein the woman can have easy access, and then it doesn't become a long way for the woman. And the main consideration was to reduce the pipeline length, not altering the site as much.
So something to think about, like if you did put it on the other side, then what could have been the scheme to take care of the wastewater part? This is not the only way to do it, and maybe not the best way. I know your site is in Bangalore, so weather-wise it's not that difficult, but it rains, so how do you access anything, right? So something that you want to think about. Another question I had was, you clearly showed in your water balance that the entire reliance is on tanker water, right? And initial. So later on you have to rely on what?
We have a daily water requirement of 24,000 liters because fresh water is required for drinking as well as for hand washing and bathing. But for other facilities, we'll use our STP and DWATS water as well as RO reject water.
This is the reality.
There's no, can't have a permanent line.
So
because
maybe
it's a
I've not
chemical structure.
understood. So you're saying that for the freshwater use, you will rely on tanker or not?
Freshwater use will be reduced.
Portable, I mean to say.
You will rely on it, yes. It will be reduced from
Over
distance.
time it reduces?
Yes.
And what's your estimate on that?
That's 49%, ma'am.
No, okay.
Firstly, we take around 30,000 liters, 45,000 liters, and then from that we reduce it by 50% freshwater consumption. So that becomes around 24,000 liters.
So the remaining you have to still depend on tanker. Is
Yes.
that what you're saying?
Yes.
That's your scheme?
Yes.
So I was curious, like you are trying to manage a lot of storm water on your site, which is rainwater. Can it not be used for portable purpose?
Ma'am, when we were looking into the water table that Bangalore has, we thought that because the system for purification was not feasible in terms of the water we were getting, and in Bangalore's current conditions, we thought recharge will be a better option.
And our catchment area was very less, so we thought it's not feasible to put another system for rainwater system.
So capturing from the roof, that water table didn't, water balance didn't
It didn't
match up?
Yeah, it didn't add up. Enough for us.
Interesting. Okay. I do have another question, which is that you did mention One second. I did see some of your daylight simulations updated. Great job. I think it's very nice to see that, from your deliverable 4, you do take the comments and the feedback in the right spirit, and you actually, this one. This is not something we had seen earlier, so good work on that. And yes, this modularity, right? You've shown an example of different configurations of the internal layout and so on. It is not clear what will, like you've said, you can put openings anywhere you want, but what is the proposal in your design? It looks like you have one door and one window. Is that all you have?
For this current design, that's what we've proposed.
So I'm not sure if that is adequate. Although you're showing, this is too tiny an image to really understand anything. With 2 people or 4 people in one room, and just like literally one window. That's something you want to again review. That is that really going to be enough as a openable area to that unit? It definitely seems inadequate. Yeah.
We'll look into that.
Yeah. Yeah, that's about it.
Hey guys, I thought that the idea is brilliant, and to try something like this for a problem which is temporal, as in if there's a resale value, which also you spoke about, after the life cycle of the project, and somebody else can pick this and just pick it up, collapse it, and take it. There's this tremendous potential in this, and I really hope that you guys will continue working on this after this, beyond the submission today. But definitely there are things that you need to improve upon. And one good thing, like from the comments that you added this, you spoke about the embodied carbon per module, you spoke about the performance per module, like the design. In terms of the performance too, while you're showing all of this, you only shown the daylighting. Had you gone into the detail of one module from the complete thermal performance perspective in detail, which is missing right now? This is only the, you're talking about the daylighting, but yours is a modular design. It's a classic example of analyzing a shoebox model and trying to deal with one in different configurations. Had you taken one as a module and had it been oriented in different orientations like north, west, all the possible orientations, and how this would behave, and how your windows can work, and also your chajjas could be solar panels, right? You don't have any chajjas right now. You can say, okay, there is tremendous potential in terms of how you can actually do it. And in fact, in the comments, I also mentioned that probably when you started, your project partners were different, but then towards the end of it, you became more automobile. And there are cases like this where people are actually working on modularized blocks, which are, there are people doing this, but not in similar way, very differently. They could have actually become your partners. It could be totally afterthought, but like I said, there's great potential in this. So analysis of one module I thought could have been extremely good. It is productized. That's also, like I thought, scalable, where you can plug it. Your site planning definitely lagged some finesse because the toilets and some of the blocks are sprinkled in between. But as a modular design, probably we can ignore it because you can always argue that there are many different configurations that are possible for something like this. That could be the strong point. But like I said, as it is, don't underestimate these basic things like the toilets and the wet areas, because people cannot walk from this end to the other end. It's not the, that's something that you should not do. And yeah, I think you said something about 1200 kgs per centimeter square as the load for the floor.
It's the rear-thumb brick that we've used as the plinth.
The plinth can take, that's the this one. Okay, but like I said, great job. But yeah, do take it forward and develop this further. This has tremendous potential to productize and take it. And if it really works, you might actually, this could be a good start for something very big in the future.
Thanks.
All the best.
Thank you, jury members. Thank you, Team Stran. Let's take a small break and get ready for the next presentation. Our sixth presentation is from Team Samshraya. They have worked on their project AIKYAM, which is located in Hyderabad. Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal like this. You won't have a 21st minute, which means at 20 minutes, I will stop you and ask you to end your presentation. After that, we will have a 10 minutes for Q&A. Please keep your answers direct and to the point. Okay, team, the stage is yours.
Construction workers build our homes. AIKYAM is our promise for us to build theirs. Good afternoon, everybody. This is Team Samshraya. Today we are here to talk about Project AIKYAM, which has been designed by a group of 12 people, keeping in mind sustainability, equity, and dignity. Our project partner, My Home, and our industry partners, Install Wall Solutions and Simply Prefab, have aided us in this project. Our project location is in Tellapur. Let's keep in mind that My Home Sahyog already has a construction working housing site near their ongoing project, which is My Home Sahyog's area. So if you move on to the next slide, you can see that the project has been considered because of the total number of people that are there on the site. We have 3,000 people on site, and their backgrounds are all of around, mainly from UP, from Bihar, from West Bengal, and they are mainly young to adults. And all of this has been done to, and our project here is to ensure that we can provide some kind of net zero addition to the already existing site conditions. Climate data suggests that we can add to up to we can increment and up to 15% of thermal comfort level on site, and that can be done through using passive control, passive techniques and material utilization. Let's look at our existing dwellings. We have congested living spaces, unhygienic sanitation, water clogging, materials which are poorly used, and poor ventilation on site. Next, please. And now we need to the reason why we've taken this project, now one might wonder why we've taken such a huge scale where there is such a big number. A 3,000 people working site requires a lot of thinking, be it in terms of sustainability, net zero, or whatever. But we still took this project because we believed, our team reckons that the same site can do better and provide better amenities and better living conditions with a very similar budget. That is what we are proposing in this design right now. Yes. So our needs and requirements based on our project partner was to ensure that there was low costing, and that it is easy to dismantle, low maintenance cost, low transportation costs, and that it is affordable. Keeping in mind the construction workers' housing requirements also, we have safe living conditions, better healthcare, better hygiene conditions, etc. on site. The goals that we had in mind was to first design better living areas, better ventilated areas, and this has been done by providing better designed units and spaces that follow standards. We also we have also designed better, safe, and hygienic places on site, and that has been done by providing platforms right under the units to ensure that the units are safe when there is water logging. We have provided better washrooms, which are located right at the two ends of the site. We've also ensured that low water fixtures are used to provide a better water performance on site. Next one. Our design approach was initially started by taking surveys from the people who lived on site, and that has been done to understand the basic living conditions on site. The climatic conditions have also been studied to ensure that our total entirety of our proposal also includes their needs and requirements. Coming to our design, initially we tried out iterations where there were rectangular and vertical iterations, But we've also looked at interlocking units and bridges which allow for more connecting spaces and communal spaces on site. We have, and we finally fixed to a pentagonal base, which worked on our site, especially because our main focus was to focus on ventilation and daylighting on site. Alternate stacking has been used to ensure that there is enough shading that is being provided just by the unit itself. Next slide. Now, looking at this site, we have two major types, the G1, the G+2 structures and the G+3 structures. Both of them, the site itself has been very organically formed, and that is to ensure proper ventilation and proper communal spacing on site. The washrooms and the kitchen and dining have been placed appropriately to ensure that there is no disturbance while moving to and from all of these locations.
So coming to the zoning of the site, here we can see the entry, and the kitchen and dining are provided at the entrance because it is easy for them to bring goods and disposal of waste. And there are STPs and groundwater harvesting at the lowest point of the counters at the site. And there is a medical clinic and school with a tot lot. And the washrooms are divided into two spaces. One is on the west and one is on the northeast for even distribution. And the spaces, and there are few courtyard spaces and communal spaces formed between the farms for gatherings or spending evening time. These are the sections of the whole site. So coming to the individual unit plans, the dining can accommodate up to 160 people, and there are 4 dinings so that they can use it at a time. And there are 2 kitchens to provide them. And the base materials for the columns are so the main structure is formed from rectangular hollow sections, and the roof is made up of trusses and aluminum corrugated sheets for both the dining and kitchen. And the kitchen has a extra storage space which they do not have now. And there is a medical clinic. There is 3 beds for resting and 1 for checkups. And there is a school in the tot lot, and there are 50 WC in the men toilets and 25 in the women toilets. So these are our proposed materials. We use low carbon steel for the its strength and reduce carbon emissions, and it is very useful while reusing. It has a long life. And coming to the aluminum with mineral wool insulation, it is used as a roof. It is lightweight and reduces the load on the structure, and it has a very good thermal insulation. And we used GRFG, glass fiber reinforced gypsum, for the walls. It is light in weight, and it has thermal insulation properties, and it can be easily assembled. And screw piles are used for the foundation because they can be reused and it needs minimal excavation. And the cement fiber boards are used for the flooring and platform because they're durable and moisture resistant. This is the structural framing of our module A. So as we can see, the blue lines are the joists and the supporting members. And this is the main beams and frames. This is the framing for the B module. So this view shows the section of the materials used in our modules. So at the top we have recycled aluminum sheet and mineral wool insulation, and then the framing is consists of 200 into 200 into 8 mm RHS section, and the supporting are 100 into 75 into 8 mm. And for the walls there is GRFG panels, and the interior consists of mineral wool insulation. And we have UPVC doors and windows, and they are double glaze panels for the windows for better insulation. And if we look at the flooring detail, there is a steel decking in between the cement fiber board and the main beam for its support. And this is the foundation detail. So the joinery is mostly used bolts and welded plates for reusability and modularity, and we welded at the places where it is a permanent structure and we can move it to the other place.
Coming to the innovation part of our design, we've come up with earth bag communal seating, which are made with discarded earth bags, side soil, and covered with a thin layer of plaster. Double-stitched cooling screens, which work on the principle of evaporative cooling techniques. And we've used mineral wool insulation for the roofs and walls, which reduce the insulation cost for up to 50%. Now let's look at how health and well-being of the workers is being taken care of in our site. UPVC doors, UPVC window casements with double glazed glasses are used for natural light and cross ventilation. UPVC doors, which are durable and easy to maintain. The bedroom accommodates 4 people, which meets the health standards for airflow and occupancy density. The blocks are stacked alternatively to improve shading. Doors and windows are placed in such a way that the cross ventilation and airflow of the units is enhanced. The blocks are placed organically with increased spacing in between for better air movement. Apologies for a small error. The base case EPI is 49.47 and proposed case EPI is 24.86. The achieved EPI is 11.5. This table talks about the total energy consumption of our site and proposed EPI. We've also used biodigesters, which produce around 178 kilowatt hours of energy per day, and the solar panels, which produce around 80% of our site's power supply. This table explains about how different materials are used in our site to improve enhance the envelope efficiency. These simulations help us understand how daylight enters into our blocks. Moving on to water performance, the main source of water in our site is the borewell, which pumps around 60% of the site's water, and the other one is rainwater storage unit. The borewell pumps the water into 3 main overhead storage tanks, raw storage tank, and then underground storage tank. The overhead storage tanks pump the water into the filter, and then that is used for cooking. The water from the raw storage tank is pumped into RO plant and then used for drinking. The water from the underground storage tank and rainwater storage is used for bathing, cleaning, and washing and cleaning. And the water from this is pumped into the STPs and reused for cleaning and flushing. The water from the toilet, the solid waste from the toilet is pumped into the sent into the biodigester and reused for and used for irrigation and sent into the ground. So there is no direct municipal connection in our site. The water management strategies which we used are low flow tap fixtures with aerators, controlled laundry practices, low flow flush for Indian toilet, timed water availability for bathing, preventing leaks, rainwater harvesting, grey water recycling system.
Embodied carbon accounts for the hidden environmental cost of the building materials from production to transportation. In our design, we focused on low impact, locally available materials to minimize the carbon footprint. We use these materials which lower the emissions and support recyclability, and the GFRG panels are resourced from within 100 kilometers from our site, so it cuts the transport emissions. Screw piles and cement fiber boards use selected were selected for reduced cement content. Our strategies include local sourcing, material optimization, and prioritizing recyclable materials. Collectively, these strategies have led to a notable reduction of 54.7% reduction of carbon emission per functional unit. Our site in Telapur has no major natural disaster risks, but some concerns remain. Monsoon winds and thunderstorms can affect the structures. Stagnant water and poor waste management lead to disease risks, and urban flooding has also been observed in Hyderabad due to heavy rains. We are in a low seismic zone, so earthquake risk is also low, and the heat waves rise up to 45 degrees Celsius, which might impact the living conditions. While overall risk is moderate, but resilient design is essential. We have solutions like tough structure and foundation for wind hazards and waste management with proper segregation. We have provided plinths, and the units are on the higher grounds, reducing the risk of floods and waterlogging. And we have provided better insulation and shading spaces to battle the heat waves. Coming to the affordability, our proposed design focuses on long-term affordability by increasing costs slightly in various aspects like civil works, services, and internal finishes. Using of our smart materials like GFRG panels, recycled aluminum, and low carbon steel, which improve the durability and reduce the maintenance and replacement needs. Though the initial costs might be higher, slightly higher in some parts, the system pays back in 2 to 5 years with significant savings in energy, maintenance, and material usage. Our strategies focus on 5 key areas like cost-effective design approach and affordable materials. We have repurposed some materials from the base case to cut down some initial costs, and we also used affordable materials and dry construction methods to save time and resources. Energy savings are coming from the solar panels and the passive design strategies, and there's water and waste management strategies, and also there's long-term costs with low maintenance finishes and modular design. Our goal is to create a comfortable, dignified home for construction workers who spend years away from their families. The design ensures a livable environment where the children grow in safety and comfort. We incorporated not only design strategies, but we also focused on maintenance, management, and governance, and it also has social and operational impact. We are focused on better thermal comfort and ventilation with organization of our units based on the wind flow tests. And we have better community formations with the gathering spaces and shared spaces like dining halls and washrooms. And there is material reutilization, and there's the layout prioritizes safety with well-marked pathways, exits, and easy accessibility. It also includes first aid and first aid support, and also essential fire safety tools.
So we need to understand that sustainability is not an ideology. It's a lifestyle. It needs to be cultivated step by step, especially in such a huge case project where there's such a huge number. We believe that since My Home is already a leading construction group, we believe that the systems and values that we are providing in this design will align with their sustainability endeavors. Sustainability starts at home. So I believe we should start with the workers who build the homes, the same homes for us. Thank you.
Thank you, team. Let's hear the jury's comments. Monish, I'll start with you.
Hey guys, good presentation. Your form is very interesting, and I don't know how practically feasible it is in terms of the density, but you have a lot of landscape in the master plan. Typically for a project like construction workers housing, I'm not sure developers if they would love to leave so much green patches, but like I said, the form is very interesting. And but when you talk about the steel, and because that is predominantly the heavily used material in the project, the first impression that comes across is that it's over-designed. So, and you mentioned a few times about the low carbon steel. So can you explain a little about low carbon steel and the cost that is associated with it? What is your understanding of low carbon steel?
So the process of making the low carbon steel differs from the traditional ones we see. So the cost is effectively a little higher than the...
How much? No. So okay, no worries. And so the question here is, what's the total steel that is used in the project? Any idea on
total weight?
Total weight of steel. You must be having in the embodied carbon calculation and also in the affordability. How many tons? 129 metric tons. Okay. And what is the total square foot of, what's the total area that you have? Build-up area. 150. 22,000. Let's say 20,000. 400 what? 400? 400 metric ton. Okay, that's like crazy. So 400, so almost like 20 kgs per square meter. That something is wrong. 20 kgs per square, that's only like 2 kgs per square feet. So something is wrong because typically in a concrete structure, somewhere the calculations are wrong because what happens is regular concrete structure where it's not fully steel, the average you can say 3.5 kgs per square feet. In your case, it will be much higher because your structure entirely is steel. That's a lot of steel. Okay, so it is possible, like you're saying, that it can be reused. But for a ROI perspective, affordability for the developer would be that he's locking that much of amount of money in a project and expecting the returns to come after some time, like probably many years, like 5 years, 10 years down the line. So I'm not sure how many people would be comfortable doing that. The idea is great, and in terms of the geometry, the form and everything is good, but you're locking the return on investment from a developer perspective, that much amount of money in your project you're putting on the steel, and you're expecting the returns to come. So that makes it, even though you can argue that it is recyclable and it has much better low carbon steel and whatnot, so that argument from this could be a little weaker. Okay, so that's one thing. Majorly, the steel is what I thought could be because you have done a lot of other things that are quite they tick the boxes, but and also in your steel, you have shown the steel in the support structure in the rooms, but not in the corridors. What happens in the corridors? There's no steel in the corridor?
No, there will be, but on a lesser density, and there will be steel decking to support it.
But steel decking is there in the floors
Yeah.
also. But there is no steel supports. You understand what I'm saying?
Yeah,
You don't have it in the drawings, right? So yeah. Anyways, like that's the major observation in your in the entire this thing. Steel comes across. It dominates all the other conversations. Okay. So that's it. And that's my.
And I have an answer for
Yeah.
using steel, because in the existing site, they are using aluminum corrugated sheets, but as the density increases, they are tending towards building G+1 and 2 structures. They started building 3 G+1 structures right now, and I think they would be more inclined to building structures like these than using the same aluminum corrugated sheets. Their project spans from 3 to 4 years to 6 years, and they have like 3-4 projects at the same area. So they are nearby sites, and there will be going on up to like 12 to 14 years from now. So I think they would be interested in something
No,
like
then
this.
it's opposite. Since the projects are running for 12 to 14 years, they're gonna lock the money for that much amount of time in steel. Getting my point? So it means that they're putting so much money. So anyways, like cost always supersedes everything, because cost ultimately decides the most of the decision. And the next factor that is interdependent is the thermal conductivity. When you have so much steel, and the structure would get heated up. So what do you do with the thermal bridges? And because you're creating a problem first, and then you'll find a solution to insulate it and all that. So these are the two things that, like, I guess the form and the massing, everything is very interesting, but these two could be like the challenges that you'll face to convince the developer to pick up an idea like this. Okay.
Good effort and good presentation. And I do agree with Monish that your form exploration was very good and interesting. I must say that you've taken on such a high density of your program to accommodate 3,000 people is not easy at all. So I could imagine you would have just figuring it out, like how many modules and how many people and all of that would have taken quite an effort. So I was curious and thought I ask you, why did you choose to do like a G+3 and then spread it on the site versus not going taller and reducing your footprint?
We would then have structural stability issues, which is why we limited it to that. And then it would also, we believed that it would also be harder to like dismantle and like move and all of that. Like steel itself is very heavy, so we did not really want to go beyond G+3 on our side.
Did you explore that option?
I mean, we did, but we just did not think it was very viable for especially such a huge number. And like each unit has around 4 people, so we also need to keep in mind the load of that it might hold on the.
I thought maybe you would have got a better sense of openness if you'd gone a little bit taller. So that is one thing. Second thing, you see this picture that you have?
Yes.
This is the existing.
Yeah, that's the existing
kind of place they live in.
Yes.
Somehow it seems to me that in your proposal,
yes,
the window sizes are more or less like this.
Yes.
And so, other than the massing,
yes,
and other than it not being exactly rectangle, how is it better or different than
This is the newly constructed part of the site that here one of our teammates was just talking about. Majority of the units on site are made from corrugated sheets which do not have any windows. There are no windows on for the majority of the units. So that was the main concern we had when we first looked at the site. The washrooms and all were also not very very sanitary, and so which is why we thought we could make it better.
Okay.
And for this structure, the windows you see right now are the only windows they have. Like only on one side of the wall they have a door and a window, but they have no other means of ventilation. So we changed it in our model for facing on 2 walls, opposite walls for cross ventilation.
Okay. There is a lot of scope to work on that. Improvise that and see how better you could make it. Modularity is also there, but in terms of the entire feel of being inside that unit,
yes, yes,
the size of the window that you've proposed seems a bit kind of not changing the feel very much. Than what we are used to kind of being in the My another question is. My next question is, I think your flooring, you have a gyp board, cement board?
Yeah, cement fiber.
What is the thickness of that?
It's 75 mm. (18 mm). Yeah, it's 18 mm.
So, and you have a, G+2, G+3. So, isn't it too thin to be a?
Yeah, that's why we are supporting it with steel decking below it, ma'am.
Still,
yeah,
it's like walking on, like a thin board. So, I don't think it's appropriate. You will it take impact? What if one runs on it? Right? It's too thin, even though you have the support structure that you need to have. But it's like placing a little tile on nothing. Right? So that's something to really think when you drop your details. Just like it needs to be resolved. Yeah. And another thing is something that other teams have also done is to, because it's modularity, either you've taken steel or aluminum or some metal, and then, but you have a insulated board of sorts. But because the members are at a certain center to center, there is a lot of thermal bridging that will happen. So the effective U value will not be as what you think it is, but it will be much higher. So that is something to consider while doing simulations, that you will have 30% or 50% bridging, and then you see if you really get that comfort inside the structure, right? So always think about it. Other than that, I want to, appreciate that you did start like your sentence with the word dignity, and that's often, it's never there considered as a thing in any of, in such construction worker housing typology. So it's something to always keep that perspective, that did you really achieve that in the end, other than the modularity and everything. Yeah, so that's about it. You want to add?
Yeah, just one small thing. I can see we have half a minute. Okay, so this is for everyone. In any project, typically, there are three things that determine the cost and the carbon footprint, major. Of course, there are many other things. Your concrete, your steel, and the walling systems. They encompass the majority of your decision making when it comes to the cost of construction and also embodied carbon. So in this case, steel, so we try to reduce, in all the cases, all the three items wherever possible to ensure the best efficiency thermal conductivity for the walls, also with the concrete, the floors and the structure, and the steel. So in your case, so you can understand what we are saying from the perspective of this, and also like we spoke about the thermal conductivity for this could be counterproductive to what you're thinking. Okay, but this is a comment for everyone. This is where we need to optimize, reduce these three materials is where we need to bring it down, because others do not contribute that much as these three elements. Okay, yeah.
Thank you, jury members. Thank you, Team Shamshreya. Let's take a short break before the next presentation. Our final presentation is from Team Augusta. They worked on their project Rhythm, which is located in Solan. So team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a bell like this. You won't have a 21st minute, which means you have to wrap it up by 20 minutes. After that, we'll have a 10 minutes Q&A with session. Please keep your answers straight and to the point. Okay, team, the stage is yours.
Good morning, all. Dignity is not a privilege, it is a right. He is a construction worker, one of the 85 living on site with his family alongside 8 other families, 24 bachelors, and 14 couples. They earn 400 to 1500 a day, and he works for 7 days and 8 hours, yet lives under a leaking roof. This is Mirju, a mason from Bihar. Like millions across India, he lives in unhygienic conditions where life is a daily compromise. So we asked, what if people who built homes finally had one worth coming back to? From this question came Augusta, a multidisciplinary team of 13 students guided by faculty, which led to Project Vridham, a co-designed worker housing solution shaped with the very people who will live in it. This project is made possible with the support from Bal Bharti Public School, who provided site access, Ethos Foundation, whose insight into workers' lived reality shaped our design, and Go Hemp, who guided us in sustainable hemp-based materials. Located in Solan, Himachal Pradesh, our site sits 111 meters above sea level inside the Bal Bharti Public School campus. Of the 2200 square meter site area, we have built on 1139 square meter. It is a relatively secluded area with the main city 18 kilometers away and essential services at least 1.5 kilometer away. It lies in seismic zone 4 and has a cold climate but requires no as such sun shading. Strong northeast winds and sandy loam soil demanded careful structural and thermal planning.
For workers like Birju, this housing is necessity. Join us as we walk through his life, restoring dignity and care. Birju's housing is designed for a steep peripheral slope connected to internal roads, while BBPS school has already flattened the site with retaining walls. We have added gabion walls for extra stability due to the slope, and road access is possible at only one point, making a single entry and exit. The layout features designated areas for families, couples, bachelors, and supervisors, recreational areas, and a store and a dispensary are placed near the entrance to limit outsider access. Toilets are easily accessible from all units. A centralized scratch ensures better child supervision. The kitchen is located near the biogas plant. Services areas are set apart from living and recreational zones for safety. The biogas plant is near the hostel and away from housing units for shared use beyond the CWH. We begin with a 3 into 4.4 meter modular unit, easy to transport and assemble. Starting with a G+1 structure, we recognized with the families, couples, and bachelors require different privacy levels. To address this, we shifted the first floor unit forward, creating a veranda below and a rear corridor above. The south tilted roof supports solar panels. Birju's home stays warm through smart designs. Shared walls keep the heat in the house, faces north-south, welcoming sunlight and blocking cold winds. His room has a north light all day. Planters before verandas block cold winds from entering. At night, the warmth lasts due to materials like deodar and thick insulations. Through it, though it defies passive solar norms, the covered south corridor and exposed north wall suit Birju's needs. Simulations confirm thermal comfort, while the corridor offers rain protection and maintains privacy, balancing climate and daily life. Here is the site plan. Ground floor plan, first floor plan, sections, and elevations. Now let's see it through a walkthrough. Birjus enters his house, walks up the stairs, and moves through the corridor, family units. He passes the crèche, and share the kitchen where families cook and eat together. Nearby is the dispensary. His bachelor friends live on first floor, and finally he reaches his own room. Outside, the landscaped area has sitting, recreational, and workshops where Birjus relax or learns new things with his friends. Construction is modular with parts fitting a Tata Ultra truck and durable materials like those in Manali's Hidimba temple. One unit needs just 4 workers and 4 hours. The full site is ready in 3 days. Walls split into 9 segments for easy panel changes. Modules adapt to any climate. For any climate, just a second. Any climate by switching wall materials and roof types like flat or sloping roofs. Let's dive into Birju's homes and see how it all comes together. Recycled steel pile foundation anchor into solar. Recycled steel pile foundations anchor into stolen soil, no digging or concrete. Instead of using complex prefabricated hollow steel joints, separate joints simplify construction, making the system easier and more practical. On the four-way joinery connects at the center, three-way joinery connects in the middle, two-way joinery is used at corners. D shows the chhajja connection. E, F, and G shows roof joinery details. Wall panel slide into. Wall panels slide into 13 grooves with panels divided into 9 segments. 100 slabs slide into grooved beams. Sliding railings and bolted stair ensure safety, and all components are tested for seismic safety. Columns plan ensure accurate column placement. The home features motion sensors, gas leak, and overflow alarms, and QR-coded local language guides for easy use, simplified wiring, speed repairs, while streamlined plumbing, bush maintenance, and hygiene. Our goal is a net zero waste system using the 5 rupees refuse non-recyclables through workshops, reduce market waste with natural items like neem brushes and bioenzymes, reuse plastics for eco bricks and fabric for covers, recycle sorted waste by local vendors, and rot wet waste into compost pits, color coded bins, manage waste. Furniture is smart and component compact. Birju's bed lift for storage. The table folds into a bed, stairs doubles as a ladder, and bunk beds fold away, all made from hemp wood and ply. All building envelope materials were selected after carefully evaluating various alternatives. Like at Birju's housing, deodar is used for its durability and natural resistance to moisture, fire, and insects. Hemp provides fast-growing, renewable, and soil-enriching materials. Fiber cement boards add strength, moisture, and fire resistance, perfect for wet areas. Marine plywood offers water and fungus resistance, ideal for outdoor and wet zones.
So this success is built on collaboration. Bamboo foundation evolved into diamond piers and wooden joinery become steel systems, guided by civil students and faculty. To combat winter cold, the biogas chambers were redesigned using solar cooker principles, with simulations confirming consistent heat and fuel. Workshops with Ethos Foundation and Geeta Ma'am's feedback shaped the design into a purposeful space, not just a structure. The Augusta app emerged through close collaboration and discussion, designed by a CSC student using Ethos Foundation insights to meet workers' real needs. It becomes a valuable companion, tracking attendance, providing government scheme updates, and offering opportunities for education and skill development. Birju uses the app to watch educational content, play games, and connect with the local marketplace. With support from faculty and ethos, we built this website as a business model where companies and individuals can explore and buy our housing solutions. With GoHem support, we explored hem-based wall, roof, and floor compositions. A live fire test confirmed safety, and the material mix helped lower U value and reduce embodied carbon. Since this housing is for workers, their feedback shaped the design. Through review, session, and interviews, we improved privacy, ventilation, and shared spaces for match their real needs. This simulation for the base case showed temperature from 10 degree to 31 degrees Celsius, while outside the comfort range. In contrast, passive design strategies helped us maintain an operative temperature between 18 degrees Celsius and 25 degrees Celsius year around, even in January. Our design meets NBC daylighting norms with 160 lux. Spaces are planned for max solar gain with panels on slope roofs for efficiency. Simulations also shows a max indoor temperature of 25 degrees Celsius, ensuring comfort year around. Wind is controlled under 0.2 meter per second, maintaining 19.23 degrees Celsius indoors. Birju enjoys evening at terraces. Green spaces are incorporated with sitting, indoor games ensured for leisure, and a reflexology path to ease stress and promote relaxation contributes to overall well-being. While workshops provide skill building opportunities, low VOC materials and air purifying plants contribute to a healthy living environment. Birju's housing need management, not just construction. So, 4 out of 70 workers rotate cores daily, while others works an extra hour. In return, all get free food, healthcare, and medicines. This routine boosts productivity and free time. Survey shows workers and owners are satisfied with this system. Special care is given to pregnant women with access to healthcare, western toilets, and a crèche. Birju's home use smart design with an energy index of 11.122 kilowatt per hour per meter square per year, 66% below the base case, giving him warmth and reliable power with the help of solar panels. This is achieved through BLDC fans, motion sensor, gas geysers, daylight use, thermal comfort, and solar panels. We choose combination that optimize the building envelopes energy efficiency. So walls, we achieved U values of 0.84 and 0.85, floors at 0.62, windows at 1.59, and roofs at 0.64 and 62. Just 8% of the roof holds 15 loom solar panels of 550 watt, producing 16,534 kilowatt per hour per year, 23.3% more than the annual demand. Through high annually, this meets daily needs and surplus powers BPPS school. A 10.2 kilowatt hybrid inverter and 5 kilowatt lithium battery ensures battery backup powers. This system costs rupees 5.9 lakh, giving Birju electricity, comfort, and energy independence. Birju uses only 64.9 liter per day water, 51% less than NBC, yet still have full water access. This is because of low flow pressure control fixtures and shared kitchens and laundries supporting centralized reuse. In Birju's housing, domestic demand is 1736 kiloliters, 1431 kiloliter rainwater harvested, 1179 kiloliter grey water recycled, 248 kiloliter black water recycled, 1018 kiloliter returned to ground. The water cycle begins with spring water used for drinking and cooking. Rainwater is harvested from rooftops and filtered. In emergencies, spring water can also be diverted to the harvesting tank. This collected water supports other domestic uses. Grey water from these activities is filtered and reused for toilets, floor cleaning, irrigation, and groundwater directed to biogas chamber, directed to recharge. Post-use, it's refiltered through the grey water system. Black water from toilets is directed to a biogas chamber for composting and energy generation. Grey water is reused through E30 chambers treatment. Black water is sent to the black water is sent to the biogas plant, and an anaerobic digester turns toilet waste into 11.5 kg of daily biogas, enough for all 66 residents' cooking needs, replacing 13.7 LPG cylinders per month. The leftover slurry fertilizes landscapes, and the insulated system runs year around without smell or failure. The result is 15.3 lakh liters more water generated than used each year.
This project reduces embodied carbon by 79% overall, 73% in structure, 134% in floors, 106.45% in walls, and 128% in roofs. Fenestrations emits carbon due to use of double glazed window, which was essential for the cold climate. Locally sourced deodar wood and hemp wool from Go Hemp cut emissions while offering strengthened insulation. Backed by supplier data and GWP of softwood lumber, Birju's home is sustainable, carbon conscious, and built to last. The design ensures resilience with deep pile foundations supporting 2000 kg loads and a frame structure for earthquake. Gabion walls and foundation reduce landslide risks. While raised plinths, elevated paths, proper drainage, weep holes, and NRC walls addresses flooding. Fire resilience includes gabion barriers, 2R fire-rated materials, dedicated fire tanks, and treating wood with linseed oil and boric acid. To tackle limited road access, an on-site store stock essentials, regular health checkups are ensured. Solar panels addresses power outages. Termite control includes citronella grass. Green belts help reduce site-related air pollution. In emergencies, food stores feed 85 people for 3 days and 4 water tanks, 5,000 liter each, meet basic needs. A 30 kilowatt hour battery powers essentials like fire pumps for 2 hours, backed by a 3,855 kilowatt per hour annual solar surplus with 30 kilowatt hour always reserved. Units can quickly convert into large halls for extra shelter. The fire escape plans show quick assembling and exit in case of emergency. The project cost rupees 8173 per square meter, but operational cost dropped by 89% with life cycle savings visible after 8 years. To make this housing truly practical for all users, we introduced task rotation, a system where workers share responsibilities between construction worker and managing the household chores. Out of 85 residents, 66 work on-site, earning wages plus 3 meals. 4 do chores with wages and meals, and 15 children get meals. Each extra hour worked earns a profit of rupees 200. The average daily wage for core workers is 500 rupees and food costs rupees 100 per person per day. Hence, calculations show the owner earning net profit of 2,700 per day. This adds up to 81,000 per month and almost 79 lakh in 8 years, allowing the owner to recover 80% of the investment from one project, and in 10 years he can earn a profit of rupees 45,000. For the owner, the modular design is reusable for new sites with minimal changes, requiring only transport costs, making it cost effective than rebuilding. Worker benefit from free meals, no cooking, better rest, and healthier living. It's a sustainable, fair housing solution for all.
Our construction workers' housing create a self-sustaining ecosystem. For the Bal Bharati Public School, it's a one-time reusable rupees 10.42 crore investment, cheaper than the 12.7 crore for conventional housing over 10 years. The Augusta app manages task, attendance, and alerts. One extra daily work hour in exchange for meals and housing ensures a full recovery of the investment in 10 years with a 45,000 profit. The true value lies with the workers. Augusta app links them to entertainment, government scheme, skills, and wellness. Housing is secure, modular, personal, with green zones, community spaces, and chores supporting work-life balance. Free food, healthcare, and services ease stress on them, while workshops offer empowerment beyond shelter. For the worker, it's growth. For the partner, a legacy. And for all of us, it's a housing with humanity. As we close, imagine a future where worker housing is a space of life, learning, and dignity. We build not just for today, but for every dream and future that deserves better. Because architecture rooted in empathy builds true belonging. Thank you.
Thank you, team. Now let's hear the jury comments. Monish, I'll start with you.
Hello. Hey guys, good presentation. And very nice quality of spaces. I really like the fact that you have taken landscape into consideration. I think some of the other teams also did it, but in your case, you give a lot of importance to the outdoor spaces for the workers, which is actually a very nice thing, because when we talk about the built and spaces, our focus is mostly on the built environment and less on the surroundings, but surroundings with little investment can make the spaces much better. So I think that's a good observation for everybody, all the other teams also in the room. There are few observations. One is your section for me somehow doesn't make sense. On one side, you're talking about not light being taken from by elevating the roof and you're drawing the light, but then you're tucking in the bottom side and creating a shade.
Yeah, that's creating a veranda space, but we have ample light from the other side.
Yeah, but what I'm saying is that on one side you're trying to do that form,
Yes.
and had it been on both the orientation, the same kind of a treatment because you're trying
Actually, we did that form due to the privacy of different living conditions. Like families prefer to live in a certain way, while bachelors and couples prefer a certain way. So, by that section, we have provided a privacy yet a community engagement. So this, it's not presenting. Like you can see from here, we have provided entrance for the families in this side, and for the bachelors, it's from the opposite side. And there is a corridor in both sides, so they can engage with each other, but still due to the lifestyle differences, they have a little privacy from each other.
Okay. And you mentioned, I gave it in the comments also that your site, they had the retaining walls and they built it. It's already flat.
Yes.
But are
we
there
have
any
mentioned.
images of that?
Yes, yes. We have this image to clarify how the site is flat.
No, this is a
This is the
diagram, a real image. You mentioned that the
No.
assumption of,
We don't have the real image.
because that's a
right
very big assumption. You're saying that it is there. That's the reason you're building it. Because in the hills, what happens is your terrain determines everything. And you're stating that this is already there,
Actually,
but
we
there is no
don't have
backup
it
for that.
right now, but I can show you later.
Yeah, but I'm just saying because in the presentation, it's extremely important.
It's not in the
because that's a
presentation.
huge, your entire building is standing on that,
Yes,
both
okay.
literally and also metaphorically, right? So that assumption. So that is really important in the presentation. Okay. Now, one huge observation that is your cost, 8,200 rupees per square meter, is not possible. Okay. Amazing details, by the way, nice details. Wood and everything that you're doing, expensive. The labor in the hills is extremely high. 8,200 rupees per square meter is equal to 800 rupees per square feet. You cannot build anything like this even in the cities. Even in the cities with these kind of details, it's impossible. In today's date, where you're talking about such nice details, finishes, wood treatment. And one of the biggest costs in the hills is the cost of transporting the material and the labor and accommodating. So what happens is, anyways, you don't have to justify that because that's not possible. 8,200 rupees per square meter means 800 rupees, less than that, per square feet. For a construction like this, or any kind of construction, that's extremely low cost.
Sir, but in our case, the cost of hemp products are very high, sir.
Hemp is only one of the components.
Yes, sir.
Right? Not everything. And whereas in general, what happens is the thumb rule calculation, if the cost of construction in a regular place is X, it is minimum 1.5 to 2 times what it costs on the hills. That's the calculation that we go with, because labor, accommodating, and also the transportation cost of material is extremely high. Okay. And one last thing before I pass on is the foundation, which again is a generic comment to everybody, is that you have gone with this thing that in the winds, especially here, the winds are extremely high, and the loose soil, because this is all filled, right? Now what happens in hill is when you're filling the soil, it takes hundreds and years for this earth to be compacted naturally, so that you're building a foundation on top. When something like this is done, where you're creating these pads artificially with pads, the soil will never get that kind of stability. It'll take hundreds of years to get that. So what they do in cases like this, either you have to drill a pile till the time you hit the natural rock below for the foundation to be stable. Otherwise, it's going to move, it's going to shift. So with the cross pile foundation that you did, interlocking, that's again, it's nice that you picked up, explored it in this. You did not mention about the structural strength and all for that. But it sinks. The whole thing will sink together because the soil is not stable. Okay?
Actually, we noticed that the soil there at our site, it's pretty hard. So it will not, and we are not
It's
digging.
filled.
We are not digging any.
No, it is filled. This pad is created manually. They created this manually.
Yes.
It will not get the right of kind of compaction for many, tens of years because it will not, because it's a soil that is filled by creating this retaining wall and a natural foundation. So when you are creating a foundation in the hills, it is understood if you're creating a foundation, it has to go and sit on the rock. Otherwise, the building will shift. And also there is going to be rains and the snow right in this. Yeah, so these are the things. I'll pass.
So first of all, I thought it was good storytelling with videos and the visuals that went with the story that you were saying. And I like that you had Birju as your protagonist. But Birju was not dressed for the cold. So I thought that was a bit off. Next time you can think about him wearing some proper clothes because he's working in the mountains. Okay. Something that I noticed that you kept repeating is that your module will work for any climate, in any location, right? And I don't know if this, this tripod-like foundation that you have, that supporting structure, will that also work for any place? Have you thought about it? I understand the superstructure, but the supporting structure.
Ma'am, we take that because the web that making that it is inspired from the how tents are used. So that's why, and it is not. Our span is not greater than 3 meters, so we have multiple foundations. So it will last as we think.
No, that is very questionable because foundations really depend on what you have on the site and so on and so forth.
Actually, the site we had, the ongoing construction that was there, they have done the shallow foundation only, but we have dug it in the pile foundations to add extra stability. And also, it is not going that far that it won't sustain in very, every climate. So
we have only gone through ground plus first floor for that's why.
So a lot of things are there. Just we cannot say that the foundation will also, we can just put it anywhere and it will work. Not to do so much with climate, but to do with the kind of soil and so on. So that is something, it needs more thorough kind of thinking. Second is, I really like that you thought about the construction workers, themselves in your innovation. And you looked at upskilling, which is a very refreshing way of looking at innovation than just looking at materials and structure. Rarely do we see thinking on the users themselves, so really good job on that. I also remember seeing you did some hands-on testing with insulation, which you had put in your report.
Yes, ma'am.
It didn't really come up. I thought you'll bring that
Yes,
as
this
well.
is the real life test.
Oh, okay.
This is the sandwich wall for the slab with the particle board, hemp wool, and hemp wood. So we also did the live test, and that's shown in the videos and photos in the presentation as well. And here also we can see it's burnt in some areas, but it didn't really gone through like it didn't catch fire. Here is the black area. We did a live test on this.
So as a student, I think such hands-on experiment really is a good learning experience, and we were quite pleased to see such experiments being done. Next point is about something very basic in your form. You know, north light is all great. And then you're saying is passive solar heat gain. For that, the wall has to be exposed. And you have a veranda.
Yes, ma'am.
So how can the two things work?
Yes, ma'am. Actually, we tried to combine this because in the south wall, it was essential to provide a corridor to prevent the bachelors from protecting them from rain because it's solar and there is a lot of rain in that environment. So it was very essential for us to put a corridor, although there was no need of sun shading, but protection from rain was a factor to be considered. So we have put a chaja on that side on the first floor, but in the ground floor, the south wall is exposed.
So there could be many other solutions to solve that. That's not the only way where you fix it and then you are not solving for the other part. You're only solving for weather protection, but not solving for solar heat gain.
Actually, ma'am, we did various simulations to confirm if the thermal comfort would be ensured in the first floor itself, and it was efficient. So we went with the idea, and also to maintain a privacy as our core concept was to ensure privacy between bachelors and family units. We feel they should have some lifestyle differences and have separate areas. So we could have easily staggered it one above other, and we could have a corridor as well and exposed south wall as well. But seeing the lifestyle was also a factor to be considered for us. That's why.
I'm not too convinced about it, but that's fine. Okay, the next thing is, I think you mentioned for doing an hour of work, extra work, right?
Yes, ma'am. Yes, ma'am.
They get an extra meal. Is it an extra meal or a meal? It was not clear.
They will do extra work for 1 hour and they will get a free meal for a whole day and for their children also. That's it.
So, ma'am, we have provided a solution. We have thought that we have provided a housing, but who will manage it? This is a question. So, for this solution, we thought that there are 70 workers on the site, but only 66 of them will be working on the construction site, and 4 will be managing the site, the household chores and everything. So
4 people.
4 people will be managing the site. We have also made a detailed schedule of them, and we have done various surveys to ensure if they were okay with it. But to manage the site, the contractor also had to manage the wages. So we proposed an idea that the 66 workers who are working on the site would work for 1 extra hour each day. So by that way, the one contractor saves 200 rupees per worker if a worker works for 1 hour extra. This was also done after surveys. So by this, he could easily easily manage the housing. He would earn a profit and he could easily provide meals. So the worker would get free meals and they would get a clean housing, and the contractor would have the recovery as well, and his project would also be completed earlier. So this was a case that we solved to manage the housing, not just to build it.
Okay. That's an interesting way of looking at it. What was the... Are we up on time? Okay, sorry. We are up on time. But thank you so much. Good work.
Thank you, ma'am.
Thank you, Team Augusta. Folks, that was the last presentation today. Today in the Construction Worker Housing Division. Our esteemed jury panel has shown immense dedication for assessing these entries, and I want to thank them. Thank you all for the thoughtful assessment and comments. And I want to congratulate all the finalists. As the jury coordinator for this division, I have had the opportunities to see these teams submit their deliverables. They have done some incredible work. Let us not forget that these teams have discovered a way to collaborate and to do integrated design during these last 9 months. I think that itself deserves a round of applause. This evening, the jury members will meet and decide the winners and the runner-up teams. Who will it be? While we wait in anticipation, don't forget to head to our YouTube channel to vote for your favorite movie. You can vote till 5 p.m. today. We have an exhibition called the Climate Smart Innovation Exhibition, where you get to see the innovative building products from the industry that addresses climate change. The exhibition is now open for you. Please proceed to the multiplex zone, which is about 5 minutes from here. And for the people who are online, stay tuned to our channel. At 6 p.m., watch the 10 exhibitors pitch their project in a bid to win the Climate Smart Innovation Award. Until then, have a great evening.